ఈడ పెట్టేసండి ఏది ఓకే ఓకే అది అది ఒకటే కాబట్టి అది పెట్టేసండి. ఇప్పుడు లాగేసి రెండు ల్యాండ్స్కేప్ తీసుకొస్తాను. హలో. అక్కడ పెట్టుకోవాలనుకున్నప్పుడు ఇలా కింద పెట్టుకోవాలి. పొడి ఉంది కదా. ఇక్కడే వేసుకుంటాం. ఇది బిగించేది అంటే కొద్దిమంది స్పీకర్స్ ఆ పీపీటీ ప్లస్ ఈ పొడి ఉండదు వాడతారు. అదేనా ఇది కొంచెం అటు ఇటు అవుతే ఇది స్ట్రీమింగ్ ఆగిపోతుంది. అవును సార్. ఎక్కడ పెట్టినా కానీ ఇది కొద్ది కదిలితే ఇది స్ట్రీమింగ్ అయిపోతుంది. కొంచెం ఆగిపోతుంది. ఇది పర్మనెంట్ గా అట్లే ఉంటారు సార్. ఈ లాస్ట్ పెడదాం లేకపోతే దీన్ని లాస్ట్ పెట్టేసాం. అంటే ఓకే కానీ మామూలుగా ఓకే. ఇది ఇది ఇంతేగా రికార్డు కూడా అవుతుంది. ఫిక్స్ ఉంటుంది. ఇంకా ఇది ఫిక్స్ ఉంటుంది. సాయంత్రం 5:30 వరకు ఉంది. జూమ్ లింక్ లంచ్ టైంలో కాదు, బ్రేక్ ఇచ్చినప్పుడు ఒకవేళ పాజ్ చేస్తారని చేయండి. లేదంటే రికార్డ్ అవుతాడు.
వైఫై పెట్టడానికి రాదా? హాస్పాట్ ఏనికి రాదు, హాస్పాట్ ఏనికి రాదా? ఓకే. ఒక రోటర్ ఉంటే ఇది ఆ నుంచి వచ్చిన వైద్యులు ఆ రోటర్ కలుపుతున్నాం అనుకో, ఇప్పుడు వైఫై అయిపోతుంది కదా, రెండు అయితే లేకపోతే ఎక్స్టెన్షన్ బాక్స్ ఉంటే దాన్ని కొంచెం ఇక్కడ పెట్టవచ్చు అన్న. ఇక్కడ వరకు అయితే కొంచెం వస్తుంది, మన సైడ్ వస్తుంది. నేను అడుగుతుంది దానికి కొంచెం ఇక్కడ చెప్పవచ్చానా, నీకు కొంచెం జరుగుతూనే ఒక 1 పాయింట్ వచ్చి నువ్వు అదే లాస్ట్ విండో వరకు జరుపు, నీకు 2 పాయింట్స్ వస్తాయి. కానీ అట్లా చేస్తే కాన్ఫిగర్ కాన్ఫిగర్ చేయాలనుకుంటా. ఇప్పుడు అనిల్ సార్ దా లాగిన్ ఒకటి ఏ అనిల్ సార్ అనిల్ అప్రాప్త నేను ఒకసారి సార్ ఫోన్ చేస్తాను అనిల్ సార్ వెళ్ళండి కాల్ తెలుగు డిపార్ట్మెంట్ అయితే ఇక్కడ దాకా రావట్లేదు. ఒకవేళ ఎక్స్టెన్షన్ బాక్స్ తోటే ట్రై చేసి దాన్ని ఇతను పెట్టుకోవడం చేయాలన్న. ఒక 2 మీటర్ అన్న రాని అన్న రాని అన్న ఎక్స్టెన్షన్ బాక్స్ కొట్టరా, ఎక్స్టెన్షన్ బాక్స్ పెద్దది ఒక 2 మీటర్ కొన్నానా ఒకటి లేదన్నా ఇళ్ళలో ఇప్పుడు ఇప్పుడు లేదన్నా ఒకటి తీసుకొచ్చేస్తాను. ఏం కాదన్నా కొన్నానా ఏం చేస్తాను అది ఎంత పెద్ద ప్రాసెస్ అన్న. ఫస్ట్ గుడ్ మార్నింగ్ సార్. సార్ మన తెలుగు డిపార్ట్మెంట్ వైఫై ఏంటి సార్? పాస్వర్డ్ సార్. హలో సార్.
A very good morning to all of you. A warm welcome to the faculty members of different colleges and students, the faculty members of NG College, Nalgonda. The program is going to start in a few minutes. In this regard, everyone is requested to maintain utmost discipline, should not make any kind of sounds. Please try to make down the notes, the speakers delivering their lecture at the time. So the humble request is that don't make noise, be silent, be disciplined students, be like a disciplined student. Thank you very much.
లాగిన్ అందులో కావాలి లాగిన్ అందులో ఇచ్చేది మనకు ఇది ఇక్కడ డిస్ప్లే ఫస్ట్ అలాంటి అందులో ఇందులో ఏదో ఒకటి లాగిన్ అయ్యి ఉండాలి. ఇందులో కూడా లింక్ డిజైన్ కావచ్చు. ఆయన మైక్ బ్రౌజర్ ఓపెన్ చేసి ఎంత ఇంకా ఉంది ఇంకొక సాంగ్ పెడతా. అల్యూమినియం అది కేబుల్ ఉందా మన దగ్గర? అది కేబుల్ ఉందా? ఇవన్నీ నీ తీసుకొచ్చా తీసుకుంటా. అరే దీంట్లో కూడా అన్నిట్లలో సాడితే ఉంది. అన్నిట్లలో ఓపెన్ చేసి ఆడ అనదర్ అని కొడతా కొట్టినా ఆడ అనదర్ సార్ దగ్గర తీసుకోలేదు అలా క్రెడెన్షియల్స్ తీసుకోలేదు అడుగు. దీని నుంచి ఆటో కేబుల్ కావాలి. మైక్ కూడా పెడతా ఎందుకని నల్గొండ అదే లైట్ సాలే సార్ లాగినే ఉంటుంది. ఓకే విశ్వామి సార్ లాగినే ఉంటుంది సార్ ఏముంటుందా డిస్ప్లే వస్తుంది కానీ లైవ్ ఇలా ఉంది వస్తుందా దిశేనా काटलेस मैच में जाना दे काटलेस मैच काटलेस मैच दे బొప్పరైతే డేట్ అయితే అయితే నెట్లో పెడదామా అది కాదన్నా ఈ కేబుల్ దానికి హెచ్డిఎంఐ దానికి పెట్టేసి హెచ్డిఎంఐ కూడా కనెక్ట్ అయి ఉందా ముట్టుకున్నా హెచ్డిఎంఐ ఇక్కడ ఉంది ఒకటి ఇంకా హెచ్డిఎంఐ ఉందా ఉందండి ఉందండి ఏది పెట్టు పెట్టి సాగు పెట్టు ఏంది your net connection sustainable hey USB huh YouTube is demonstrate దాన్ని తీసి అదే అదే ఇది పెట్టించు ఇది పెట్టండి దీనిలో షేరింగ్ అయితే లైవ్ టెలికాస్ట్ అయితే లైవ్ కూడా ఇది చూడండి ఆల్రెడీ ఉంది కదా ఇప్పుడు యాడ్ చేసి అడ్మిట్ చేయండి ఆడ అడ్మిట్ ఆల్ పైన షేర్ అంటే వీడియో అలాగా దాన్ని పిన్ చేయగానే అంతేగా స్క్రీన్ పెద్ద కనపడుతుంది ఫుల్ స్క్రీన్ చేస్తారు అంతే అంతేగా ఈ పెద్ద సాంగ్ ఓపెన్ చేయను అది కాదు ఇంకోటి ఓపెన్ చేయను ఇలా బోర్ కొడుతుంది
ఇది పిన్ పెట్టేసారు.
అది పిన్ పెట్టేసి
On behalf of the Faculty of Life Sciences, Nagarjuna Government College, Nalgonda, it is my great honor and privilege to welcome you all to the two-day national seminar on sustainable development goals and the role of life sciences to be conducted on 25th and 26th. Respected principals, sir, respected dignitaries, and all the faculty and the dear students. Let us start this program by inviting our guests to come on to the dais. Firstly, I invite our principal, sir, Dr. S. Upender, sir, the president of today's function, to come on to the dais. Thank you, sir. I now invite our chief guest, Professor T.P. Radhakrishnan, sir, School of Chemistry, University, to come on to the dais. I now invite our keynote speaker, Professor Ramachari, sir, Professor of Chemistry, University of Hyderabad, to come on to the dais. I request the convener of today's program, Dr. M. Anil Kumar, sir, Assistant Professor of Chemistry, to come on to the dais. I also request our IQC coordinator, sir, Dr. Y.V.R. Prasanna Kumar, sir, to come on to the dais. Let us also invite our co-convener for this program, Dr. B. Anil Kumar, sir, Assistant Professor, Department of Chemistry, to come on to the dais. And most importantly, I also invite the organizing secretary of this program, Mr. Nagaraju, sir, to come on to the dais. I now invite our vice principals of our college, Dr. P. Ravi Kumar, sir, to come on to the dais. I also invite our Vice Principal Social Sciences to come onto the desk, Dr. Antati Srinivas. Next, I invite the Head Department of Botany to come onto the desk, Srimati Shivrani Madam. Now let us honor our guests by presenting a fruit bouquet. Now I request our convener, sir, of this program, Dr. M. Anil Kumar, sir, to present a fruit bouquet to our principal, sir. I request our principal, sir, to honor the speaker, the guest speaker, and the keynote address speaker for today's program. Firstly, let us honor Professor T.P. Radhakrishnan, sir, by our principal, sir. I request our principal, sir, to now honor Professor Ramachari, sir, our keynote speaker. Let us start today's program by the lighting of the lamp. I request our principal, sir, and all the dignitaries on the dais to accompany, sir, in the program, in the lighting of the lamp.
లైట్ ఆడించినప్పుడు ఏదో పెడతా చూడాలి కలర్ కలర్ దానికి పెడతా అయిపోతుంది యూట్యూబ్ ఆన్ చేసి అట్లా ఇస్తాను పెడతా అయిపోతుంది ఆట అట్లా
I request Rupa Madam, MGO Department of Chemistry, to join us in the lighting of the lamp. Continuing the proceedings, I now request our principal sir, Dr. S. Upendra sir, to give us the welcome address.
Good morning to everyone. So, respected senior professors on the dais, Professor Radhakrishna sir, so Ramachari sir, and conveners of this program, Anil sir, M. Anil sir, B. Anil sir, Vice Principals Ravi Kumar sir, Antar Srinivas sir, IPC Coordinator Prasanna sir, and the Organizing Secretary Nagaraj sir, and the Head of the Department Sivarani madam, and Josna madam, and respected teachers and my dear students. So I am very happy to conduct this national seminar today and tomorrow for life sciences and chemistry. So this is a very important seminar. This seminar is interact with the senior professors, all of the renowned professor to interact the teachers and students. So empowering in the subject research wise and the higher education side. So most important of this one. So I am very happy, sir. So senior professor Radhakrishna sir, we interact the so many issues of the undergraduate level last half an hour. So what is the NEP? How it is the in higher education? So what are the opportunities? Sir has also represented the National Academy of Sciences. So I interact the sir. So sir give the so many suggestions. It's very useful. So because of this seminar, we interact the sir, and the so many programs are there. And I am happy to announce that another resource person, Senior Professor Ramachari sir, is the product of this college. So and immediately of my junior, I completed 93 degree year, sir completed 94 years, same MPC Telugu medium. I am very happy, sir. So this is the very rare opportunity to interact the senior professors, University of Hyderabad. So conduct the various programs undergraduate level. So my college is the almost all 4,000, around 4,000 students are there, sir. So all courses conducting the BA, BSc and BCom and BA courses, sir. So so many students are aspirant of the higher education. So this is platform very useful to students and teachers interact with one. So thank you, the organizers, the organizing the seminar. Thank you, sir.
Thank you, thank you very much, sir, for your wonderful words of encouragement. Now, let us continue the proceedings with the release of the souvenir by the dignitaries on the dais. I now invite the convener of today's program, the young and dynamic Dr. M. Anil Kumar sir, Assistant Professor of Chemistry, to come onto the dais and say a few words about the seminar.
Sir.
Good morning to the dignitaries on the dais, our principal, Dr. Upender sir, and the esteemed professors of University of Hyderabad, Professor T.P. Radhakrishnan sir and Ramachari sir, and my co-convener and organizing secretary, and my principal, vice principals, and my teammates in this conference, zoology and botany HODs, and the force behind all the seminars and quality activities, IQAC coordinator Dr. Y.V. Prasanna Kumar. A very happy morning to you all. This morning, let me introduce the today's seminar in a nutshell. What we are going to learn, what we are going to take home from this seminar. Let me briefly introduce about the seminar. So the first inaugural session, this is the inaugural session. We unveiled the brochures and the souvenir which we have prepared. It contains all the abstracts received from various teachers of the colleges all over the country, and students or research scholars from the country. They have sent the abstracts, and we have compiled it in a book. This is called Souvenir. So this will be given to all the registered faculties and students just after the inaugural session. And coming to the topics of the seminar, our resource persons, as many of you know already, I have shared in the WhatsApp group the eminent speakers for this seminar have taken from all the fields. You might have seen the names or photos of the speakers. Three are very I cannot say old, they are very experienced professors, and three are young professors. So associate, assistant professors, three are there, around 45, below 45 age, and above 50, there are three. So it's a mixture or combination of both the groups, young professors and experienced professors. So first start with the senior most professor T.P. Radhakrishnan sir. So sir will be delivering the first lecture, nanomaterials, uh, how it is useful to our topic, the sustainable development goals, how we can reach sustainable development goals through the life sciences, chemistry, botany, zoology, microbiology, biotechnology, etc. And second topic will be, second session will be dealt by Professor Ramachari sir. As sir announced, sir is our NJ college product. So sir will be delivering the second lecture. And third, Dr. Balakrishnan sir, he is from Telangana University. He'll be dealing with the life sciences applications in achieving the sustainable development goals. So, and the fourth one will be Dr. Shamlal, animal biology professor from University of Hyderabad, one young professor. So he'll be dealing this topic today, the last session. So with this, the day one ends, and in between, from 2 to 3, all the abstracts that we received from various colleges, universities, they will be presenting their topics between 2 to 3. So that 1 hour, some of them may come online and some of them will be presenting here orally. So that will be for today's technical session. So for that, you will have a few professors who will be evaluating, and at the end of the day, we'll be announcing a best poster or best presentation award also. And comes to the day 2, Dr. Ayodhya, he is also from Nalgonda. He is working as a patent officer. He will be talking about intellectual property rights and how a country can see IPR, or how IPR can help a country to be seen as a intellectually developed. So that topic will be taken by a young scientist, Dr. Ayodhya. And another one is Professor Gangaraju, Brainpool Professor, Chuang-Ang University from South Korea. He will be addressing the biosciences and the applications. And Pro VC Vice Chancellor, Dr. Nagajyoti Madam, she is PhD in chemistry and PhD in data science. So both computer science as well as the life science. So both the sciences will be, she'll be dealing. So she'll be dealing how the life will be made easy with the help of the sciences. So the last session will be again valedictory session, last day of the second day at 2:30 to 4 p.m. This is the overall schedule of the program. So ultimately what we want to achieve from this seminar is to create an understanding or inquisite towards the science, how the science is helping the people in the whole country, or as per UNO, the 17 goals of SDGs are from as per UNO. How we are helping as a science students, how we are going to help to this SDG, Sustainable Development Goals, which will make life easier. Just I will read out few Sustainable Development Goals which are really helpful to us in this seminar. If you see in the souvenir we have printed, SDG1 talks about the end poverty, how a poverty can be ended with the help of life sciences we are going to deal, and SDG3, good health and well-being. Good health and well-being, and zero hunger, SDG2, life and land, human life and animal life, and life below the water. All these things are, all these goals are achieved by only science students and teachers only. So by the end of this seminar, I or we as an organizing team expect that everyone should think on these lines to help the society. So I hope these two days will be a learning for all of us. With this remarks, I conclude. Thank you very much, Principal Sir, for giving me this opportunity to conduct this national seminar. Thank you very much.
Thank you, Anil sir, for giving us a bird's eye view of the schedule of the 2 days of the two-day national seminar. Let us now hear to the words of wisdom by our chief guest, Professor T.P. Radhakrishna sir. I request sir to come on to the desk and say a few words.
Good morning to all of you. Respected Principal Dr. Upender, all the Professor Ramachari, who is my colleague from University of Hyderabad, all the heads of department, head of IQAC. I'm really grateful for this opportunity to be here today. Dr. Anil Kumar called me several days back, and I had not been to Nalgonda before. So I thought this is definitely a good opportunity for me to be here. And later I learned that my dear colleague, Professor Ramachari, was also an alumnus of this college here. So it's a great pleasure to be here. So I thank the organizers for inviting me here, and Dr. Anil Kumar, who has been continuously in touch with me. Nalgonda, I learned, has an extremely great past, especially from the viewpoint of academic thinking, spirituality, and so on. And this college is really blessed to have the name of Acharya Nagarjuna, who I understand in the 2nd and 3rd century CE, AD, established the Mahayana line of Buddhism in this part of our country, with monasteries, Buddhist monasteries being set up in all kinds of various regions like Rachakonda and Nagarjunakonda and Panagallu and several other places. And I think that old historic beginnings has had an impact over the years. And that's obviously the reason why in 1956, a few years after the Hyderabad state was assimilated into the Indian Union, this college was started by the missionaries of that day. And I believe it started with a very small group of 60 students. And today it has grown to nearly 4,000 students. And that's a very important progress, especially considering that this was and continues to have a rural environment. I have seen the city has grown a lot, but I think that still the rural ambience still exists in this part of this state and our country. And I think that the rural background and environment is very important for the growth of individuals. And this college in particular, I have seen, has produced great luminaries who have served as vice chancellors of universities, Indian civil service officers, and scientists like Professor Ramachari here. He's one of the leading organic chemists of the country today. And this is all due to the roots that are developed in colleges like this. In fact, I know this personally because I myself studied in a much smaller college than this in northern part of Kerala many years back, last century. And that upbringing in a rural environment, I think, gives us a perspective of sort of a down-to-earth perspective in our life. And that, I think, gives a lot of human values which you use when you progress in life. And I think the students here are blessed with that environment. The only thing I would add is that after they finish their fundamental studies here. They should go out into the world. And when you go out into the external world, you recognize the importance of the rural background that we come from. So that is very important, and for the progress and for them to contribute further to the society and nation and so on. And I think this is wonderful to be here. And I noticed one more thing, the topic of the seminar, this 2-day seminar is sustainable goals, sustainable development goals sort of listed out by the United Nations. But it's interesting that the mission statement of the Nagarjuna Government College has the word sustainable development in it. It's there on the plaque, it's there on the web portal. And I think that sustainability is a natural offshoot of the rural background that we cherish. I thank all of you once again, and I'm hoping that I'm sure the 2-day program will be very fruitful to everyone. Thank you.
Thank you very much, sir, for your encouraging words and enlightening us about the historical aspects. I now invite our keynote speaker, Professor Ramachari, sir, our alumnus, to say a few words.
Good morning, all. Respected Principal Garu, Dr. Upender, and my teacher, my colleague, Professor T.P. Radhakrishna Garu, and other Anil Kumars, both, I'm very happy, and other teachers and students. I'm very happy to be here today. First happiness is you people did great job that bringing my professor here today. You can see that is also very sustainable. Today I am a good scientist means because of my teacher. So the way you have seen the few sentences how clearly explained to you what is the importance of Nalgonda and all. Even I don't know that much. The way professor he goes through everything systematically, he explained who we are. So you can imagine 2 years I learned from him in chemistry. Then why not I become more sustainable in the subject? So that's what teachers should be great. So automatically students will come very systematically. So with that few, but I'm very happy here today. And through my lecture, I will talk some more detail about the subject and all. I really wish that this 2-day program should go really excellent manner, and especially students. This is a great opportunity for you people to listen clearly, carefully what the speakers are going to tell about the subject and your future. And you should come out the future scientists and whatever you choose should be the great manner. That inspiration should take this coming 2 days. And with these few words, thank you very much.
Thank you very much, sir, for your kind words. As much as you are proud of your teacher, we are also so proud of you and so happy to have you with us today. I now invite our accuracy coordinator and head department of English, Dr. Y.V.R. Prasannakumar, sir, to say a few words.
Dr. S. Upender, Principal and Chairman of the occasion. Professor T.P. Radhakrishna, Professor of Chemistry, University of Hyderabad, Professor Radhakrishnan, Professor Ramachari, Professor of Chemistry, University of Hyderabad, Vice Principal, Dr. Ravi Kumar, another Vice Principal, Dr. Antar Srinivaslu, Convener of the conference, Dr. Anil Kumar, Co-Convener, Dr. Another Anil Kumar, and Control of Examinations, Mr. Nagaraju, Head of the Zoology, Dr. Joshna, Head of the Botany Department, Madam, yeah, and all the dignitaries of the dais, on the dais. Thank you for giving me the opportunity. And it's really, I'm very happy that today NG College keeping its name up, is conducting this national seminar on sustainable development goals, roles of life sciences. And the UNO has declared 17 sustainable development goals, out of which I think few are taken for this conference, and most importantly, 14 SDG 14 is taken, like life below water, which focuses on marine preservation. So this is very important aspect here, and I really am happy about this. It is really very important to have these goals, and the goals are meant to be achieved. We need to be focused on the target of achieving these goals. We need to concentrate on that. It is not just teaching something to the students, but helping them to understand what is meant by sustainable development. So students and faculty together can achieve this sustainable development goals and go further in the future. The future depends on this. Our future and our students' future and the generations to come, they have bright future if you concentrate on this. I want you to also include one aspect in this sustainable development is concentrate on Indian knowledge systems. Indian knowledge is packed with this sustainable development. It started with that, and as rightly mentioned by our chief guest, that it's rural areas are inbuilt with the sustainable development. So that comes from the Indian knowledge system. I would like to end with a quote by Lord Krishna from his address to Arjuna, that he says, "It is not, we do not success with the resources, but we get success with the resourcefulness." Thank you so much. All the best.
Thank you very much, sir, for your encouraging words and your suggestions. Now we have come to the most important event of our program, where we are going to felicitate our guests who have accepted our invitation and taken time to spend some time with us. So let us felicitate our guests. I request our principal, sir, conduct the talk. First, we will all felicitate our chief guest of the program, Professor T.P. Krishna, sir, School of Chemistry, University of Hyderabad. Thank you very much, sir, for accepting a small memento of appreciation. Now I request our principal, sir, to felicitate Professor Ramachari, sir, our proud alumnus, and we are so happy to have you with us, sir. Concluding. I now request the dignitaries on the dais to felicitate our principal, sir, Dr. S. Upender, sir. Thank you very much, sirs, for accepting our small mementos of appreciation. Now I invite Dr. B. Anil Kumar, sir, the co-convener of this program, Assistant Professor of Chemistry, to say a word of thanks.
A very good morning to all of you. I would like to say one sentence here before proposing vote of thanks. Sir, really, our college and all the students, we are very happy to have you here, sir. The great scientists and professors from School of Chemistry, University of Hyderabad. On behalf of organizing committee, we are expressing heartfelt gratitude to the principal of our college for supporting us to conduct this program in a successful manner. Thank you very much, sir. And we are really very happy. We are expressing our heartfelt thanks to Professor P.P. Radhakrishnan, sir, a well-known academician and scientist from School of Chemistry, University of Hyderabad. Thank you very much, sir, for coming here after traveling long distance. Thank you, sir. And it is my pleasure to propose vote of thanks to the Professor D.B. Ramachari, sir, alumnus of this college. Sir, thank you very much for accepting our invitation and coming over here. Thank you very much, sir. And I thank, on behalf of organizing committee and college, to the convener of this today national seminar, Dr. M. Anil Kumar. I thank organizing secretary, Bathini Nagaraju, sir. And it is my pleasure to propose vote of thanks to the IQSC coordinator, YVR Prasanna, sir. And I take this opportunity to propose vote of thanks to the principal, vice principals of this college, Dr. P. Ravikumar, sir, and Dr. Antati Srinivas, sir. And I am also proposing vote of thanks to the HOD Department of Botany, Shivarani Madam, and HOD Department of Zoology, Dr. Josna Madam. And I am also expressing heartfelt thanks on behalf of organizing committee to the participants participating in this student national seminar from various colleges of Telangana state. I thank the faculty members of this college and also to the students. Thank you very much. With these words, the inaugural session is concluded. Thank you. Now it is 10 minutes break for tea. After having tea, let us gather here for the technical sessions. Thank you all.
ఇదేంటిది ఇది డొంగిలా ఇది లైఫ్ డొంగిలా ఇది ఏంటిది తీసేది పైకి పెంచారా వైట్ చూసుకుంటాం వైర్ చూసుకోండి వైర్ 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 ఓకేనా ఇది పీపీటీనా ఫుల్ స్క్రీనా ఫుల్ స్క్రీన్ బాబు పైకి ఓకే కాపీ చేసుకున్నాం ఆ కాపీ ఇది వస్తున్నాయి. ఓకే రావట్లేదమ్మా జూమ్ వస్తుంది. ప్రవీణ్ డన్ దేని దేని పిల్లలు ఇది 4:3 రేషియో, ఇది 4:3 రేషియో. ఓన్లీ బ్యానర్ మాట్లాడుకుంటుంది. సారీ సారీ ఎన్సీసీ వాళ్ళు ఎన్సీసీ సార్ చేస్తున్నారు. లైవ్ సార్ ఒకసారి పీపీటీ ప్రజెంట్ చేస్తున్నా. అర్థం కాలేదు. ఇది ఇందులో అదేదమ్మా ఇది కాదు, ఇది ఎలా సైడ్ చేంజ్ సైడ్ చేంజ్. ఇది ఏ సార్ సార్ ఇది ఫస్ట్ ఆయనదేనా సార్? ఇప్పుడు వీళ్ళు మామూలుగా మోబుల్ ప్రొజెక్టర్ తెచ్చారు కదా, మోబుల్ సార్ మనం ఇది ఫిక్స్ చేసి దీంట్లో నుంచి మనం ఇస్తున్నాం సార్. అదే మోబుల్ ప్రొజెక్టర్ పెట్టడానికి హ్యాపీనే ఇస్తున్నా కానీ ఒకటి
డియర్ స్టూడెంట్స్, నాన్న మీరు ఎక్కడ కూడా ఇబ్బంది పడకుండా ఫ్రీగా ప్రశాంతంగా కూర్చోండి. చాలా ఇంపార్టెంట్ టాక్ ఉంటుంది, చాలా మంచి విషయాలు మీరు నోట్ చేసుకోండి. బీ అలర్ట్, బీ అటెంటివ్ అండ్ బీ సైలెన్స్. థ్యాంక్ యూ. Come back. Collar mate. Once again, good morning. Now I welcome our MGU, Department of Chemistry HOD, Rupa Madam, onto the dais. Madam will be chairperson for this session. I request Madam to occupy the dais. Now I request Professor T. Radhakrishnan sir to the dais. And I request Bakri Nagaraju, Assistant Professor Microbiology, to occupy the dais as a rapporteur. Now I hand over this time to Rupa Madam to further proceedings.
Good morning to one and all. I welcome all gathering to the first technical session of the today's program of which is organized by the Department of Chemistry and Department of Biotechnology together for the two-day seminar on sustainable development role, the role of life sciences. Okay. I'm very much privileged to introduce today's first speaker of this program, Professor T.P. Radhakrishnan, sir. Sir has completed his PhD from the Princeton University in the year of 1987. He completed his postdoctoral research from the University of Texas in the 1988. He served the IIT Madras as a scientist for three years. And later on, he joined as a faculty in the University of Hyderabad, and now at present is working as a professor in the University of Hyderabad in the School of Chemistry. And his research area interest is design and synthesis of novel molecules of materials and molecular crystals, nanocrystals, nanoparticles, polymer metal nanocomposite thin films, etc. And he has also very good interest academic recognizations. Sir has been awarded as Young Associate of the Indian Academy of Sciences, Bangalore in the year of from 1990 to 1995. Sir has been recognized as Indian National Science Academy Young Scientist Medal in the year of 1992. Sir has also received a Swarna Jayanti Fellowship from the Department of Science and Technology from 1998 to 2003. Sir received Bronze Medal of the Chemical Research Society of India in the year of 2002. He also has been received the Sir received the Silver Medal of the Chemical Society of India. Sir also a fellow of the Indian Academy of Sciences. Is also fellow of the Institute for Advanced Studies. Is also fellow of the National Academy of Sciences. Is also fellow of the AP Academy of Sciences. Is also fellow of the Asian Pacific Academy of Materials, and is also working as Associate Editor, Journal of Chemical Sciences. With this brief introduction, I request Professor T.P. Radhakrishnan, sir, to give his lecture on this occasion.
Thank you. I don't know if people at the back can hear me. Well, there are still some seats in the front. Those people who are sitting in the back can come forward. Okay, I think if you can hear me, I start. Then they are fixing the projection. So let me just quickly thank again the organizers and welcome all the fellow teachers and students here. This is a very important topic, the broad theme. My talk itself will be more of a technical one. I'll try to touch upon those points which are related to sustainability as we go along. And while waiting, I would also like to welcome all the students here to the University of Hyderabad. Whenever the principal and your teachers can arrange your visit. Professor Ramachari and I and all our colleagues will be happy to welcome you at the School of Chemistry, to show you around the department and talk to you. We have a large number of PhD students there, very active research in all areas of chemistry. So please remember that, talk to your teachers and arrange a visit. We are very happy to welcome you. So now that this has come up, let me start. So nanomaterials is a very important area of science and technology. So obviously it has connection to various areas of sustainable technology like energy, environment, and so on. And this is my email address because I always make it a point that especially the students who are the future scientists should keep in touch with all of us who come here and visit you. So email address is there. So any of you, because sometimes in the talks and seminars, you don't feel like asking questions. Okay. So you are welcome to send any questions, queries, suggestions, advices, and so on to the email address. And some details of the department and our research will be there at this portal. And happy to be here at Nalgonda. I think, yeah. Will this work? Okay, okay, fine. So, this is the main theme of the seminar today and tomorrow. Now, okay. So, as was already mentioned by Dr. Anil Kumar earlier, the United Nations proposed these goals in 2015, and the target is just 5 years from now. By 2030, supposed to achieve many things, essentially targeting the peace and prosperity of the world. World meaning specifically such people and the planet. That word is important. Not just us, the whole ecosystem of animals and birds and fish and so on and so forth and trees. So there are several points here which you can always look up on the web. I'll try to look at in particular or I have to move here. So, for example, clean energy and good health, industry, clean water. These are some of the points I will touch upon as we go along. Because obviously a single branch of science cannot address all of them. But as we go along towards the end of my talk, I will touch upon some of these. But rest of it will be basic chemistry and basic science of nanomaterials. So you can see nanotechnology touches many things. In fact, this is just a partial list. It addresses computing, materials, manufacturing, health and medicine, because this is also a program targeted at life sciences, energy, environment, transportation. So there are various fields in which nanomaterials and nanotechnology makes a big impact. And what is important, because I work in the area of materials chemistry, so I look at things from that perspective. So nanoscience, this doesn't move. It will be easier if I can change the slide. At least no.
Clear.
Is it because of the distance? I can talk from here. Yeah. Okay.
Distance.
Okay, fine. So, nanoscience and nanotechnology touches a lot of subjects. For example, that is why I think it's important that because this program is also addressing students from life sciences, chemistry, biology, and so on. So you can see it touches many, many areas, biology and chemistry and energy and medicine, engineering, and so on. So, but what is interesting is that the connection between all of these comes through the domain of materials. So that is why I've titled it as nanomaterials. And being a chemist, I will look at it from a chemistry point of view. So I'll start with history because history is important, as I mentioned in the morning also. The Nalgonda's history is something that is very important for everybody here and elsewhere to remember. Same way, the history of civilization. There's a nice book by somebody called Durance. There's a story of civilization. It's more about how the story of philosophy and so on that came up. But what is interesting is these are just some pictures coming from history textbooks about the Neanderthals, Stone Age, Copper Age, Bronze, Iron. All this is the way we describe the story of civilization, how human civilization grew over the historic period. And now, of course, you talk about Silicon Age, as you know, all these computers, everything inside this, for example, there's a lot of electronic devices. So they work on silicon, and people say carbon age is coming. That means a lot of things will be based on carbon. And interestingly, moving. Okay. So, for example, silicon, carbon, these are all from the periodic table. And these are why I put this slide. Yeah. So there is a specific point. Yeah. Okay, I will talk like this. Okay, fine, no problem. See, geography is important. Yeah. Okay, let me see this works. So the materials basically define our civilization. So how our civilization grew, everything is based on the material people use, stone or iron or bronze. So even our existence is closely interacting with the materials that we use. So for example, materials come in many forms. Just for drinking water, we use so many different materials. For example, metals, steel glass, or plastic, ceramic glass. Glass is basically ceramic, basically metal oxides and so on, or polymers. So these are all different forms of materials serving the same purpose. And there are many more. We need not go into the details of material science. But what is interesting is if you look at materials, I put pictures of 3 different compounds, which most of you students in BSc or high school would have also seen. Okay. So these are some crystals of different compounds. I don't know, students can guess what these are. What is this? Yeah. Okay. So this is basically copper sulfate, dichromate, nickel chloride, and so on. They should come one at a time. Okay, no problem. I think maybe I take too many. So these are all very different chemicals, and they look very different. Their solubilities are different. Their reactions are different, and that is because they have different chemical composition. These are all materials with the same chemical composition. They are all carbon, pure 100% pure carbon. But then their properties are also very different because, for example, graphite is very good thermal conductor. It conducts heat. But
It also conducts electricity. Whereas you think okay. So diamond, for example, is a very poor electrical conductor. And this is fullerenes or carbon 60 that you might have heard of. There are a lot of fullerenes and so on. They are highly soluble in organic solvents, but these are not. So they're all very different in properties, and not because their chemical composition is different, but because of the structure, the way that atoms are bonded are very different, as you can see. So that means the chemical composition changes, properties change. Their structure changes, properties change. But now let us take another example. This is silicon. You might have heard of silicon many times, but this is how a silicon rod looks like. And if you take it and grind it in a mortar, this is what you will get. If you go on grinding, this is what you will get. So suddenly, some change has happened in the material property. From here to here, there is practically no change except that particles have become smaller. But here, color has changed. In fact, if you grind it further, it will become red and so on and so forth. So what is happening here is a very interesting question. Because all the three cases, the chemical composition is same. They're all silicon, 100% silicon. Their structure is the same. They're all bonded the same way, tetrahedrally bonded silicon atom. But then, how come there is a big change in the property? The color. Color is an important property. So many colors right now here. So the change that has happened is in the size. So this is the essence of nanoscience. When size changes at very, very small range, going from millimeter to micrometer, not much change. But micrometer to nanometer, there's a lot of things happening. Now this is very curious. Why at nanometer things should change? This has to do with the fact that size of atoms and molecules are very close to that. Atoms are typically angstroms, that means 10 power minus 10 meters. So that is about 1/10 of an nanometer. So when things come to the atomic or molecular sizes, properties of materials change. So size is an important. This is the only important lesson in nanoscience. For example, if you take, there is a beautiful site of, which is called Hours of 10. This is taken from the web. This is a picture of the Earth from somewhere in the space. Diameter of Earth is approximately 10,000 kilometers. Diameter. That means 10 to the power 7 meters. Now we go on focusing into small regions like a small square shown here. You go on focusing it, you will see, you go to the trees, then leaves, the size becomes smaller and smaller. The veins of the leaves, they are typically centimeters in size. Cells are typically a few hundred microns or so. If you go further down into the nucleus, it is typically a micrometer, 10 power minus 6 meters. Then you have the DNA strands, in biology we learn this, and you are reaching the nanometer range. So finally, the nucleotides are typically of the size of a nanometer. DNA strands width, for example, diameter is typically. So in nature, we have so much of variation in size. For example, the Milky Way, which is the galaxy in which the Earth lives, is of the order of 10 power 21 meters, the size, almost 100,000 light years. And the smallest things that people have figured out, subnuclear particles for quarks, high energy physics people talk about, is of this size. And what is interesting is the nanometers come somewhere in between. And that is roughly the size of a few atoms or a few molecules. And that is why a lot of new physics, new chemistry, new biology happens there. And this is the length scale for conversion, millimeter. You divide a millimeter into 1,000 parts, it becomes a micrometer. Take 1 micrometer and divide it into 1,000 parts, you get a nanometer. So this is a few atoms together, or a few hundreds or thousands of atoms. Now, thousands of atoms is a very small number. If you remember the idea of an Avogadro number, Avogadro number is a mole, the concept of moles in chemistry. Avogadro number is 10 to the power 23, very large number. So 10 power 3, 10 power 4 is a very, very small number of atoms of blood. To get a feeling of size, these are pictures of natural objects, like our hair is typically a few hundred or micrometers, something we can see with our naked eye. Something like blood cells, you cannot see with our eyes, but if you have a microscope, in biology labs, you have this microscope which run with the light. There are microscopes which use some other radiation than light. We will come to that later. So these are based on optical microscopes or using light. You can see micron-sized objects. Things like DNA, they are extremely small. The width of DNA molecule is only about 2.5 nanometers. Ordinary microscope, if you use, you cannot see a DNA molecule. Why? This is an interesting question in physics. We will touch upon it as we go along. But you can image them using modern microscopes, which use not light, but electron beams. So why that is important will come along. Right? And there are a lot of man-made objects or human-made objects. For example, all these micro and nano objects which are fabricated. For example, carbon nanotubes. They are like DNA molecule with few nanometers. There are things called micro electromechanical devices and so on, which are used in medicine to control blood flow and things like that in human beings. So there are many landmarks in the way the nanomaterials have come. And one important one is, there are many, I will touch upon a few more things as we go along. The famous lecture by a famous physicist called Richard Feynman in 1959, he talked about the importance of small objects, working on small scale. And that was one of the beginnings when people realized at the nano size, nanomaterial, new kind of physics and chemistry and so on can happen. He is a Nobel laureate in 1965. But the evolution of nanotechnology started long, long before Feynman. For example, the ancient days, again history and chemistry and physics and science cannot be separated. This is not Nalgonda, for example, is near Hyderabad. Udumanalli is somewhere in Tamil Nadu. Mysore, Karnataka, Malabar is in Kerala. Very long time back, 500 years before the Christ, people had developed something called wood steel. This was a cottage industry in many of these small villages, where iron was melted and then they used to make steel, and that gives very high tensile strength. The tensile strength of material means you can bend it and not break it. High tensile strength is needed to make swords, for example. So, for example, this Tipu's sword was made from this wood steel, and modern analysis has shown this steel is not just iron. Obviously, steel has carbon, but carbon can be in many forms. If carbon is in the form of nanotubes, then these are basically nanotubes here. Modern microscopy has revealed it. That gives it high tensile strength. So nanotechnology was at work even in our villages long time back. They did not have a microscope picture at that time, but now we know it. And there are many examples like this in Europe. Various colors of these ceramics were given due to gold and silver nanoparticles and so on. Many windows in the cathedrals in Europe, the color is again due to gold and silver within the glass matrix. So nanotechnology has been evolving over a period of time. And today you have all kinds of modern textiles. For example, in textile, there's a lot of nanotechnology. Like this is a dirt or spill resistant fabric. They have very, very fine hydrophobic regions on the cotton or any other fabric, which makes it the liquid cannot seep through that. Capillary action doesn't happen, so they will not get wet. I mean, if you want a shirt which will not get drenched in rain, you can use nanotechnology. And there are a lot of in television technology, video screens, and so on. A lot of carbon nanotubes technologies have come. Huge number of products are there in the market today which use nanotechnology. This is slightly old data, but today there are maybe about 2,000 or so products in the market which use nanotechnology. Just to highlight the point that this technology is important and the science behind it. But being scientists, whether you do life science or chemistry or physics or mathematics or biology or earth science, whatever, we need proof That is the underlying principle of science. Seeing means that's not necessarily with the naked eye, but using some experiment we should be able to observe. And the catch is these tiny, tiny objects like DNA strand or a carbon nanotube. You cannot use even ordinary microscope to see. Now, what is the reason for that? How to see things? For example, if you switch off the light, this I did, but no, it's nothing to do with the slide. Okay. But come on. If you switch on the light, then there is small time delay. These electron waves are a little slow. So these objects you can see when you switch on the light. Why? Because the light hits those objects and get reflected. They go into your iris and to the optical nerve, and it recognizes that an object is there. But if you have, of course, a very small object like a stomata and leaf, which are again biology students often look at, you need a microscope, and you use light, and then you can magnify it using various lenses like quartz lenses and so on, and you can see tiny objects become bigger so that our naked eye or a camera can capture. Now, the problem with this whole business, when you go to tiny objects like nano size, is the following. A lot of deep physics is there, but I'll try to quickly explain using the very basic idea. If you use visible light, we all know that they are electromagnetic waves. They have a certain wavelength, they have a frequency and velocity and so on. So, if you take red light, for example, the wavelength is approximately 650 nanometers. Blue light is around 400 nanometers. Now, imagine a particle which is only about 50 nanometers or 10 nanometers, much smaller than the wavelength of the visible light that we, because human eye can distinguish light from about 400 nanometers to about 700 nanometers or 750, blue to red. So the problem is, if you have very tiny object, there is a fundamental physics phenomenon called diffraction. So the diffraction is spreading of light. So there is a fundamental principle in optics that if you have a light of wavelength lambda, you cannot focus it to a size smaller than about approximately 1/4. This is called the diffraction limit. That means any light will simply spread. So what is the problem? If I have a 600 nanometer light, I can focus it down to approximately 600 by 4, about 150 nanometers, not less than that. So if you have a particle which is only 5 nanometers or 10 nanometers, and the light is spreading so much, you cannot distinguish the particle from its surrounding. Everything will look the same. That means you don't have what is called contrast. It is, to understand this, a simple analogy is the following. If you have a brush which is about 1 inch diameter, you can draw a line which is 1 inch wide, but it's impossible to draw a line which is much thinner. So because the brush is so wide, it is impossible to draw a very fine line. Same thing happens with the light. Because of the spreading of the light, you cannot view an object which is much, much smaller than that diffraction limit. So that means you cannot use an optical microscope to see nano objects. Then what do? People have come up with various solutions to the problem. One is called electron microscope. Now, not only light, electrons can also show wave property. This is something that we learn in quantum mechanics. So, depending on the speed with which the electron travels, actually the momentum, that determines the wavelength. There's a famous relation called the Broglie relationship, which says if you decrease the wavelength decrease the momentum of the electron, the wavelength will go on increasing. Or if you increase the momentum, the wavelength will go on decreasing. They are inversely related. So you can use electron microscopy. If you can make the waves only 1 angstrom or a few angstroms in wavelength, then you can use it to do microscopy of nano objects. Another one is called scanning probe microscopy. I'll just quickly show pictures to quickly see what it means. For example, this is our transmission electron microscopy. There is electron beam. Now this is very similar to an optical microscope, except in optical microscope you have light It goes through the specimen and through quartz lenses, and then you view it by magnifying. But here you use an electron beam, because electron beam you can have very small wavelengths like angstrom or so. Angstrom wavelength means 10 power minus 10 meters. That means much less than a nanometer. So you can use very small wavelength, and you cannot use quartz lens because quartz will also be ionized by electron beams. You use electromagnetic field. You have electromagnetic coils which can make these electron beams diverge or converge or focus and so on. And you send it to a sample and you can view it using appropriate detectors like CCTV detectors. So this is one technique. This is how an electron microscope looks like. As I said, welcome to University of Hyderabad. We will show you how an electron microscope looks like. We have in the campus somewhere. And here electron source is there and the sample will be kept here and you can capture the image. And this is a kind of images. This is from some literature. This is actually graphite layer. And if you look at, I'll show you better pictures later on. You can actually see the hexagonal rings in graphite. If you remember, graphite has 13 rings connected together. So this is basically graphite, or a single layer is called graphene. And the idea of atomic force microscopy is a very different one that is also used to see nano objects. It works on this principle. Most of the youngsters here has never seen this, but many of the older people here would have seen it. This is how we used to listen to music in the early days, using what is called a gramophone record player. Basically a plastic sheet with a spiral cut into it, where the information is encoded, music or speech and so on. And it has a fine pin which moves on that. This will rotate with a motor. The pin will go up and down depending on the dips and ups and downs of the spiral. And that movement is picked up by electromagnetic coils, converted into electrical signal and sound signal. So that is how we used to listen to music in the early days. This works on the same principle, except that instead of a pin, you have a very, very sharp tip. And that tip is here. It sits on a sample which has only nanometer objects, nanometer sized objects. Now, between any two atoms, there is a force called van der Waals forces. So that is the word force. It's atomic force. Basically, between the two atoms of any kind, there is always a force. If they are charged, you have electrostatic forces. Otherwise, you have still van der Waals forces. Using that force, you can image what is on the surface. Because the objects are very tiny and the forces happen across a few angstrom distance, you can see whether there is a bump, a big particle or a small particle using this microscopy. There's a lot of technology involved in designing, and I will not go through those details here. But it's very important that the movements are extremely tiny. These are created by what are called piezoelectric materials, where you can move a sample along small dimensions like angstrom at a time, and you can develop an image. For example, this is how a atomic force microscope looks like. We have one or two in our department, in School of Chemistry there. You come and we will show you. And you can record images like this. This is actually a monolayer film. That is just a layer of molecules which we have prepared in our laboratory using what is called a Langmuir technique. I'll show you that one later. It's just a single layer of molecules because the thickness of the sample is only 2.5 nanometers. Using atomic force microscope, you can actually see. So the first point is that you can observe nanomaterials using electron microscopy, force microscopy, and so on. There are many other techniques. So that means the chemists or physicists or biologists can now study DNA molecules one at a time by using these kinds of techniques. So where does the chemistry part come? Many ways in which chemistry is important here. One is to do with the fabrication. How do you make? Because all science also depends on whether you can make those objects or those samples and study them. So making, again, if this is a nanoparticle, this is a schematic. You can start with a large particle and break it down using grinding, for example, that I showed you for silicon. Or you can use atoms or molecules and combine them, let them grow in a controlled way and form a nanoparticle. So this is called a top-down and this is called a bottom-up approach. These are terms now politicians also use. when the top leadership dictates what you should do, it's called a top-down command. But if as students or teachers, we decide how the college should run, that's a bottom-up approach. So, long time back, chemistry started being, for example, silver nitrate. There's something called tolerance reagent used in chemistry labs. So basically, if you have reducing sugars, if you add silver nitrate, you will get a silver mirror. So this is a silver mirror test for reducing sugars like glucose and so on. So if you do that in a controlled way, you use a reducing agent like alcohol or monohydrate. But if you don't let these crystals grow into a thick film, you stop it at the right time by using something called surfactants or stabilizing agent, then you will get nanoparticles. Now, one of the very early experiments was done by Michael Faraday. This is actually a solution of gold. Now, impossible to imagine. Gold, we know, is a metal, very hard metal, solid film or ring, jewelry, all this. But you can dissolve gold in organic solvent. This is actually carbon disulfide solvent. How did he do that? He took something like fluorouric acid, it's not a gold chloride. Oh, this also. This. Yeah. So this. Okay. So he basically used some gold chloride and used phosphorus as a reducing agent, and he made the solution. And this color is very beautiful. In fact, you can get blue solutions, purple solutions, and so on of gold by changing the size. And that is all nanoscience in some sense. And this is very stable. Even today, it's present in some museum in London, and after some more than 150 years. Another way of making, that is using atoms and making them into tiny particles and stopping their growth using CS2, carbon disulfide, as a ligand on that. Now, you can also do what is called Langmuir blot technique. The picture I showed you of a monolayer film earlier is prepared using a technique developed by Langmuir and blot long time back. These are the years in which it was started. So basically, if you have surface of water on which you put some surfactant molecules, typically surfactant molecules which has a hydrophilic head group and a hydrophobic tail. So this is how actually the trough looks like. The Teflon trough. We have one in the laboratory. So if you spread them on that, now you use some barriers, again made of Teflon usually, and if you compress them, you move those barriers, then these molecules, because the tails cannot go into water because they are hydrophobic, they don't like water. And heads are hydrophilic, so they get stuck in water, like carboxylate groups, phosphate groups, and so on. And these are hydrocarbon chains. And if you go on compressing, them, these molecules get packed. They get packed into a single layer, and you can follow all this by measuring surface tension and so on. There is something called pressure area isotherm. So as you compress, the pressure will go on changing. The surface tension keeps changing, and from that you can measure the surface pressure. And if you dip a glass plate or some substrate into that, you can transfer the monolayer, and you can get this kind of. So using this kind of a molecule, you can make monolayer films. And if you add some DNA into that, basically they become thicker because there's a layer of DNA also. So all these are things, fabrication of nanomaterials. Many methods are there. I just showed you a couple of them. Interestingly, you can also do what is called top down. That means take large particles and break it down to tiny particles. Again, interesting example comes from our Ayurvedic medicine. There's a famous thing called Swarna Bhasma, there is Tamra Bhasma, there are various bhasmas in Ayurvedic medicine. And this procedure comes from the 15th century, 4 or 5 centuries back. Now, what did they do? They took a piece of gold and subjected it to a series of steps, mixing with some mercury sulfur and so on, and heating it at very high temperature in a furnace, earthen furnace, using cow dung furnace, you can make and get very high temperatures. People have used thermocouples to measure. Now we know it's almost 900 degrees Celsius. And finally, it forms a red powder. Now that is exactly like that Faraday's solution. Instead of using a gold ions and making them into gold atoms, here you take bulk golds, break it down into fine powder. And apparently there's therapeutic values. It is good for arthritis and various health issues. Now people have seen using electron microscopy, those powders contain 50 nanometer size gold particles. So this is a fine example of a top-down. And there are, of course, many modern examples using what is called scanning tunneling microscopy. You can remove atom by atom using a high voltage. These are very expensive techniques. Or simply using a Scotch tape. This is again very famous example of graphene. Some of you might have read there was a Nobel Prize given for this discovery. If you take graphite, a thick piece of graphite, use Scotch tape and peel off one layer at a time, finally you will reach a single layer. Those are called graphene. That's again a top-down, thick one, almost becoming a single layer. So these are all techniques by which you can make them. Now there is another important connection to chemistry and basic physics. What is that? That is something called conceptual. That is in terms of principles, not just making things. What is the connection principle? In chemistry, we handle molecules. In biology, also you handle molecules. They are the important things. Professor Ramachari will also talk about synthesis of molecules and so on. So that is an important concept in chemistry. Now, nanoparticles are very much like molecules in many ways. I'll give a reason why I say that. And nanoparticles are also materials, as I have seen already. I'll talk about applications later on. Now, that means nanoparticles and molecules are also like materials. Single molecule is also a material now. You can do many things with that. Why do I say that? This is a picture I put earlier. How does the color come? There's a lot of underlying physics there, but very quickly to tell you, if you take a piece of gold, as you know, it's a good electrical conductor. That means electrons can flow through gold very well with very little resistance. There is a resistance, but very small resistance. Copper, platinum, these are all good conductors. Now, why does it still have a resistance? That is because when electrons are moving under an electric field, they also hit the vibrations of atoms and defects. So they get detracted. So you have a resistance to the electron. Now, typically electrons can travel a few micrometers within gold without getting scattered. Now, if the particle is much smaller than that, that means a few nanometers, the electrons can basically oscillate across these particles. They can move up to the edge. They cannot leave because the nuclei charge will pull it back. They set up an oscillation. Depending on the size of the particle, the oscillation frequency will change. And if you change the color, if the oscillation frequency matches visible light, then light gets absorbed. It's called a resonance phenomenon. So if the oscillation frequency is typically that of a blue light, then the blue will be absorbed. So it will transmit the red. So you get the complementary colors. If you change the particle size, the color will change. Now this is exactly similar to the way color comes in dye molecule. This is methyl orange, which we use in titrations and so on. The color of methyl orange has to do with the oscillation of electrons between the ends of the molecule. This is called a charge transfer between the head to end. So this electron oscillation is very similar to electron oscillation in the particle. And I took deliberately two similar looking colors. So all this, you can have various kinds of colors in a particle. You can have variation of colors. This is something called quantum dots. If you remember, 2-3 years back, there was a Nobel Prize given for finding out what are called quantum dots and making them, showing the color variation. This color variation has to do with a little bit of solid state physics. When the particle size becomes smaller, the energy gap between the electron states, either HOMO, LUMO in molecules or valence and conduction bands in solids, will keep increasing. And this again a quantum mechanical effect. And because of that energy gap change, the color which is absorbed or emitted will change. These are very important in applications which I will briefly touch upon. same thing happens in molecule. You take a olefin, you go on increasing the polyene structure, the absorption energy will keep on decreasing. So this is how you get dye molecules, all the beautiful colors, all the cloths that we wear. The color comes from dye molecule. The color of the dyes has to do with the electron absorption. And electron absorption and light absorption due to electron excitation. For very extended conjugation, the energy gap comes in the visible range, so they become colored. So they have very, very similar principles. And chemistry is, of course, has a lot of importance in the central subject. It happens in many places. In the atmosphere, chemistry happens in the earth forest. So occasionally to wake up people who are sleeping. So, yeah. So it happens on earth. Not very smooth. Okay, the point is that chemistry can happen in various places, including the lens. This picture is interesting. This is actually organic chemistry done at a single molecule level. Using probe microscope, you can actually watch a single molecule, and by heating, some ring closures happen. Different isomers of the molecule form, and you can actually image the molecule today using atomic force microscopy. And this is something which we have been developing in our laboratory to give us an example of simple ways in which you can make nanoparticles. One can make particles within a polymer film. Polymer is thin polymer films like polyvinyl alcohol. Why is it important? For example, if you take a metal like gold and a polymer, they are very different materials. One is very hard, the other is very soft, light, opaque, transparent, a lot of difference. However, if you make the metal in the form of nanoparticles and polymer as a thin film, then you can make what are called nanocomposites. These are extremely important today in a lot of technologies. So we developed a simple method where you take a polymer film, inside which you have incorporated some metal ions. You basically mix the polymer with something like silver ions or gold ions or salt, make a thin film, and if you keep it or shine light, the film can actually, if you have hydroxy groups on the polymer, it can cause reduction of the metal ion to metal atom. And because of the heat, the metal atoms can combine and form particles. So within the film, you have done some chemistry, you have done some reduction of metal ions to metal atoms and making them into nanoparticles. You use basically the same technology that you mentioned earlier, except that something like polyvinyl alcohol is a polymer as well as a reducing agent. So you can basically what I just now said, if you pour a film and keep it, you can actually convert metal ions, for example, gold ions have light yellow color. Once you reduce them, you get this pink color. So you can do chemistry within a thin polymer film. The film is only about a micron or so thick, very thin film, but you are doing some chemistry inside that and creating nanoparticles. You prove it, of course, using electron microscopy and so on. And basically, this is the reaction that happens. Basically, tolerance created chemistry. The hydroxy groups will get oxidized to ketone, and the metal ion, silver ion, gets reduced to silver ion. And you can do this with various metal ions. For example, palladium is a very important catalyst for a lot of organic reactions. You can use the same chemistry, palladium 2+ goes to palladium 0, and this is the chemistry that happens. So you can do a lot of chemistry within a polymer film, generating nanoparticles and so on, some microscopic images. Now, all this said, so I broadly, very quickly went through 2 or 3 points. One is how to observe nanomaterials using microscopy, how to make them using various techniques like solution chemistry or high temperature chemistry and so on, top down, bottom up. Now, finally, the question will arise, why do we make it? That is where, of course, various applications come. I just mentioned there are innumerable applications. Just to tell about catalysis. Now, this is a picture which shows a cricket ground. Many of the youngsters will be happy to see a cricket ground after some time, a lot of chemistry. See, why do I show this? Over? Okay. then I will run through very quickly. So catalysis is important because when you break a big particle into very tiny particles, the surface area, you get very large surface area. And these are important catalysts. So I'll run through, I'll not go into detail. You can make films with catalyst inside and use this using what is called a dip catalysis. You make a polymer film with particles inside, they are good catalysts. Using that, you can run reaction. Run through this. Okay, this is just, I should mention, this is one of the important sustainable development goals. For example, in industry, scaling up reactions without affecting the environment. Here, the catalyst particles are within a film and recyclable. So this is important from an industry point of view. You can extend this to electrochemistry. Again, because of time, I will not go into detail. Out of time. So this is again very important. Electrochemically splitting water, you can generate hydrogen, which is an important fuel. Affordable and clean energy. This is another important goal. Sensing. We can use nanoparticles and their color changes on exposure to metal ion. Very important for good health and water and well-being and so on. Purification of water. These are all details of that. And nanoparticles are also very good bactericides. So this is a technique we developed long ago, very simple technique where you can generate silver nanoparticles inside a polymer film and use that to purify water to kill the bacteria. So this is without stirring with this rod. There is a lot of bacteria growing in the water, but once you stir it with this polymer which contains silver nanoparticles, you kill all the bacteria. So this is also important from the point of view of clean water. Clean water is again an important sustainable development goal. And there are a lot of other antibacterial techniques using nanoparticle tubes. And this quantum dots that I mentioned is very important in medical diagnostics. So by injecting some nanoparticles, we can actually get very high contrast in this imaging, medical imaging. Using conventional dyes, they are very poor images, but with nanoparticles, you get very, very good contrast. So I will conclude here, saying that I looked at the importance of nanotechnology and understanding the chemistry connection and trying to relate it to various sustainable goals. Just a couple of pictures. This is a beautiful picture of copper with carbon fullerenes sitting on that. This is the fullerene. This is then be used to count. This is done using an electron microscope and so on, scanning tunneling microscope. They're all, it's a gold rod plate which we developed in our lab long time back. It's a textbook on materials chemistry. I'm supposed to show this slide at the end of my talk, which I have written. Thank you very much.
Thank you, sir, for giving us a very effective lecture on the nanoscience. Any queries from friends or any faculty or participants? Thank you so much, sir, for your exemplary lecture. I'm a botanist, sir. I wanted to know about the microcarnation, how it is related to nanotechnology, sir.
Okay. Because of the time constraint.
Yes, sir. Just skipped out.
So that is some kind of vanadium phosphate. It's from some particular group. Basically to show that they have very high surface area. They are used in some hydrocarbon industry as a catalyst. But the point that I could not explain is that when you take a small cube, which is 2 centimeter cube, if you cut it into nano-sized particles, you calculate the surface area. It's a few acres. So very large surface area comes up. And the catalysis happens on the surface of these catalysts, called heterogeneous catalysts, right? So that nanoflower is just one example. There are many catalysts like that. It could be particles. That particular preparation gives you a lot of surface area. Therefore, high catalysis, very efficient catalysis. That is all that.
Thank you.
So thank you so much, sir. I'm not from any kind of science background, but thank you very much when I mentioned about IKS, Indian Knowledge System, and you brought it here. Swarna Bhamsa and all that. Thank you very much, sir. It was a wonderful lecture.
Now I request to give vote of thanks. Address.
Thank you, ma'am. It is my privilege to extend heartfelt thanks. So we have understood about nanomaterials and chemistry connection. Has been both. This lecture has been both insightful and inspiring. We witnessed the fascinating journey of the nanotechnology from ancient innovations like wood, steel to the cutting edge applications of modern nanoscience. So this SAR's presentation mentioned us and reminded us this size truly matters, and advanced tools such as SEM, AFM, atomic force microscopy, and STM. And we also noted the chemistry connection in nanoparticle synthesis, the creation of nanocomposites, and their diverse applications in catalysis, sensors, healthcare, and sustainable energy solutions, all aligning closely with the United Nations Sustainable Development Goals, sir. So on behalf of the organizing committee, I sincerely thank Professor T.P. Radhakrishnan, sir, for the thought-provoking lecture, and also thank the chairman, the guiding the session, and also thank all the organizing committee members for their meticulous efforts, and also thank the participants and dear students for your patient listening. I thank you, and with this, the session is concluded. Thank you, one and all.
Without any further delay, let us start the next session. I now invite Professor Ramachari sir, Professor of Chemistry, University of Hyderabad, to come us to the dais. Please, sir. The chairperson of this session, Dr. D. Ramesh sir, Assistant Professor of Chemistry, Mahatma Gandhi University, Nalgonda. Please come on to the dais, sir. The rapporteur of this particular session, Srimati V. Sirisha, a faculty of botany, to come onto the dais and take over the proceedings. I now hand over the proceedings to the chairperson of this session.
Thank you, ma'am. Very good afternoon to one and all. So let us start the second session of today's seminar. So on behalf of MG College Nalgonda, Faculty of Life Sciences, and Principal and Vice Principal, I warmly welcome you, all of you, for this 2 days national seminar on sustainable development goals, the role of life sciences. It is my privilege and honor to introduce today's keynote speaker, Professor Ramachari Garu, Senior Professor of Chemistry at the University of Hyderabad. Professor Ramachari Garu obtained his PhD in synthetic organic chemistry from the Indian Institute of Science, Bangalore in 2001 and carried out postdoctoral research at USA in 2005, and where he is currently leading the catalysis laboratory, and he is distinguished scientist and fellow of 4 prestigious academies, that is National Academy of Sciences, Royal Society of Science Chemistry, London, Indian Academy of Sciences, and the National Academy of Sciences, Allahabad. And Professor Ramachari Garu has guided over 22 PhD students and 14 postdoctoral fellows, with several of them received the prestigious PhD thesis awards. And his scholarly contributed include more than 125 high impact fact publications, 2 books, give big hands for him, 2 books, and innovative research in organic catalysis with the same chemical reactions named after him. In addition, he serves on the editorial boards of leading international journals such as Organic and Biomolecule Chemistry, Europe Journal of Organic Chemistry, Tetrahedron, and others. He has delivered more than 165 invited lectures worldwide and continues to contribute actively as a reviewer and member of the various national research committees. Sir, we sincerely appreciate your gracious presence here today and sharing your knowledge with us. I also thank Principal and Vice Principal of the NG College and the organizing committee members for taking the initiative to conduct this important seminar. We are privileged to have Professor Ramachari Garu with us today, and on behalf of all present, I now cordially invite you, sir, to deliver the keynote address. Thank you, sir. Thank you. Now I hand over to the professor to deliver the lecture. Thank you, one and all.
Good morning, all. Thank you very much for inviting me here. Today, very happy that today I am sharing with my teacher. When you are introducing me, I think a little shy in front of my teacher, telling things and all. But I am very happy. You can say, when you say about the sustainable, serum, స్థిరమైన ఎక్కడి నుంచి వస్తుంది స్థిరం? How it will come from స్థిరం? I see this college, I'm very happy to show that and go in the college. So my AG college is, I studied here 91, 94. This is my picture from here. Exams time I have to get the hall ticket, right? This is my hall ticket for the degree college, degree third year, and degree first year the intermediate teacher is, and this is my 7th class. 20 kilometers. So just 20 kilometers from here, Thirtical. I am from Thirtical. So, when we talk about sustainable, స్థిరమైనటువంటి భావాలు, the professor told morning, the rural, how strong we should be in the rural background, how to construct. So for that, this is our, I have a very passion to go to library. After these classes, then we'll go have lunch and come back. After the lunch, no classes will be that much. Only morning, only more classes. Then after lunch, then I will run to the library. Know more about the Telugu literature. By mistakenly, I joined HPC. I should have gone to PhD, Telugu history, political science. And I am more fashionable in Telugu. So I used to go and read more about the poets, actual real sustainability in Telugu literature. Extraordinary scientists, like the way we have a great scientists, we call about how much the great people constructed the science. Similar manner, the great Telugu personalities construct our language. Desha Kaushalandu Telugu lesson. The beautiful language constructed. Many of nowadays people won't go through the literature nicely. How you construct your personality, how sustainable. So I am so passionate on this stranger. This is the one that made me to go to more science side. Swaros is a Manusambhavam. This is the one epic. When you read the people, you'll understand how beautiful science is there in that. Those days, sir, the poets used to make the more science in the poetic main in the lyrics. So in that, it tells that the way the Brahman, one Siddha will come to his home, he want to go to Himalayas to see entire Himalayas. To go Himalayas not easy to go and come. But the Siddha who came is the chemist. He will put the like a small nano material to the legs, bottom of the legs, or entire leg, whatever. Then he will fly. He will fly from the Kanyakumari this side, whatever the one. He will go to Kashi. Then he will go through all beautiful places. The way they explain about that. Then you want to come back, but entire labor is gone. So we cannot come back. That's a great story. So that time I understand that that kind of material is there. Then I should study chemistry more. Then I more fashionably from second year onwards I started moving to the chemistry side. But my first year chemistry is 45 marks. I'm not that much fashionable. Then I want to do my masters in the chemistry. That's what intermediate 10th level chemistry teachers don't give that much beautiful manner to explain what is the chemistry. More fashionably, again I wrote my supplementary, means improvement. I want to test myself whether I get the more than 90, then I will go to MSc chemistry. If I did not get, then I will go to mathematics side. I am good in mathematics. Then I got the 90 marks in my improvement. Then I got myself, yeah, you are good for the chemistry, let's go to the chemistry. So that is the foundation came in HG college. Then after this, one is my father. So so many these things he used to teach me. Then after that, I am lucky that that's the word greatness goes to our teachers, NG college teachers. Before me, I think many people used to go to Usmania University, Kakatiya to do the master, but we never have a dareness to go to University of Hyderabad. That is the little bit I read. Still, I don't understand why. Because we have a beautiful college where international level teachers are teaching there and great labs are there, extraordinary equipment. Why we won't utilize the University of Hyderabad to do a masters? That is in our state only. The central university is in our Hyderabad. Very less number of people will come. And I am lucky that I am a Telugu medium here. First 2 years Telugu medium. Then when I asked the people used to tell, it will be there, University of Hyderabad in the English medium. Then it's not easy to write the exam. Then I sat, I requested the teacher Krishna Reddy and all, Narasimha Rao garu, and all, sir, I want to sit in the English medium. Oh, Ramachari, no problem. You sit. So I used to sit 1 year in the English medium. Then I wrote the entrance. Then I got this is the University of Hyderabad, my MSc program. So I'm lucky that my teacher used to teach me in computational chemistry and material chemistry, extraordinary manner, and that is the beauty. Where is the sustainable? When you have a great teacher like Vishwamitra, Vasistha, Parashurama, then definitely your students will become Ramas, Krishnas. But if your teacher is not strong, you cannot become a great person. So I'm lucky that I have a great teacher. You can see that in the lab. In this, all are well settled. He is from Mysore Bhopal chemistry. I am from here, and he is also computer scientist. Everyone all are well settled. Well, I did my masters from my master teacher Professor Hiriya Sami. So that is the Sukun one. So that is the word. Rasayana Shastram Rasaramyam. When you understand the chemistry, Then we'll do all entire Kuchipudi, Bharatanatyam, everything we can understand through chemistry only. Whatever outside will be more beautiful than Srinjivi dance. If you understand the subject, if you not understand, then become a Kankaral. If you understand the subject, entire beautiful dance will come into your brain. So that's what I like very much. Well, so yeah, this is the life science people are conducting this symposium. Well, that's what mana Puranalo and Pedal. Try to understand yourself. Means first you know who you are. That mean is entire one is there in the in the nature, in the plants and the animals. How things are existed. Whatever a plant we and all did not exist from just within 100 years, 200. It came from the so many million years. Million years is came parampara. This parampara is going on, going on. Today we are like this and enjoying. But where we came, so that we should understand the science and try to bring the beautiful things, and we are trying to utilize for our betterment of our life, whether it's medicinally, materially, philosophically, psychologically, whatever. So that is the word. When we see in the chemistry point of view, how the life science is existing in the plant or animal, is a catalyst. So catalyst, well established catalysts are there in the body, and they will catalyze the reactions, especially life cycle on earth is the catalyst engine participate in most part of the life cycle to understand everything. And when you see the enzymes, that is the two kinds of the metallo enzymes and metal free enzymes. So metal containing enzyme is the polypeptides. Is the peptide is the macro amino acid containing. Amino acid will form the peptide bond, and that once the length of the one professor talked today morning, it's small level how and big level how. When increase the length of the protein, that become extraordinary one catalytic power, and that become enzyme. That kind of enzyme can be metal or metal. The both will be there. It is their metal containing enzyme. Normally in organic reactions, we'll take enolate reactions, enolate mediated reaction. But this also will act as the enolate. Lot of enzymes are there, and you can see the how the enolate generation. That is the aldolase enzyme, zinc one, and will generate the anion, will come zinc enolate, and zinc enolate is the nucleophile, will go the aldol reaction. The aldol product. Normally in normally it is normally in the laboratory LDA, sodium nitrate and all, but in the sensitive life cycle we cannot do LDA reaction, but in the life it will be happening very simple matter. Zinc will be activating and form the enolate, and that enolate will go for aldol reaction, aldol products will form. And this is the one another kind of metal free aldolase one, and this is the way it will go very nice systematic lysine amino acid containing one. The lysine is going attacking on that, then will break on that, will form and will form the very nice. This is the imine and enamine, and this enamine acts as a nucleophile. How sensitive reaction in the body, in the plant body, animal body. It's outside in the laboratory will take care so much harsh manner, because that's what జ్ఞానం వచ్చినప్పుడు ఎంతో అద్భుతంగా ఉంటుంది. అది లేనప్పుడే మూర్ఖంగా ఉంటుంది. అది మన బయట చేసేది కొంచెం లో ప్రొఫైల్ ఉంటుంది, బట్ ఇంటర్నల్ గా ఎక్స్ట్రాడినరీ ఫ్యాషన్. Smooth reaction that still sometimes surprised that how nicely cutting the bond and constructing the philosophy of the plant system. So this is the way. So when we talk about the enzymes and all, is the macromolecules, right? If you decrease the length of the enzyme, you become antibodies. The small antibodies also act as excellent catalyst. And thanks to the corona. In the corona time, you know what is the value of the antibodies. So he is the one, my supervisor, Carlos Barbas. His postdoc used to work more on antibodies. He has 4 companies in antibodies. 4 companies in antibodies in San Diego. He worked on this 38 AB38 antibody, and that antibody also acts as the allulose 1 enzyme. Allulose enzyme big molecule, antibody target small molecule, and they have the same attitude. Lysine amino acid is the lysine amino acid enamine will form, and this enamine will go lot of reaction. What I'm trying to say is, we understand the nature, how it is working there, and we try to understanding that and minimizing the enzyme to antibody. Antibody level we understood very clearly. This antibody also is that the lysine amino acids react with the carbonyl, will form enamine and react with other carbonyl, selective manner. Aldehyde product will come, it all equilibrium step and idolize, and aldehyde product will come out, again will go reset. We understand very clearly. So still sometimes antibodies getting not easy. Why not only one molecule catalyze? See how level of understanding. In 1970s, from Germany, Ajas, he able to use instead of peptides, so antibodies and all, only one molecule amino acid, acid group, amine group, and cyclopentane. In this molecule, three functionalities are there with one structure, and this acted as a catalyst. This is the triketone. This is the triketone. This is the catalyst able to go cyclize the reaction and able to get the product with the 95% yield. These MSc students are there. How many? MSc students. Oh, but 60 students. What happened? We have 60, right? 60 first year, 60 second year. Any Chiranjeevi movie released today? No, right? That's like sometimes we just Chiranjeevi movie release remains. Right, we will go first. First show like that. Any first show is there effect? Exams are there. But they should have sat here today. So it's a very interesting. Switch off that. So very interesting, students. I know if this is the molecule, that molecule have a plane of symmetry. This molecule have a plane of symmetry, and this catalyst can react with this carbonyl, can react with this carbonyl, can react with that carbonyl to form the imine. But selectively going that fellow only this carbonyl because of the steric, because the steric tendency is there, and reacting with that one and forming enamine, and whether it can react with this carbonyl, that carbonyl, and that is called facial control. And this is a dissymmetrization. A selectively dissymmetrizing only one carbonyl to mark asymmetric dissymmetrization through intramolecular aldehyde reaction to make the aldehyde product with high selectivity. In organic chemistry, we can draw the reaction, but without understanding mechanism, a second person cannot use that reaction. Bad luck, this reaction 1971 discovered, but did not understand the mechanism. It did not expand to other reaction, other purpose. But they explain the mechanism. The others did not understand what they are trying to explain. And this is the one Swaminathan from our University of Madras, our scientists also tried to explain, but did not get the more clarity manner. Others did not understood. So they did not expect, they did not feel that, they did not believe that this is the suitable explanation. So that's why they did not go more detailed utilization of this reaction. Then in another one, same time, in 1971-72, another one, the same six-membered one. Chemistry went very nicely. You know, this is the five-membered, and this is the six-membered. These two are very, very important for the steroid chemistry. This is the AB ring of the steroid, and this is the CD ring of the steroid. These two molecules used to come pure chiral compound, cages. They used to mix together and get the steroid, and they used to make a lot of cages for the entire planet. Because in 70s, 80s, a lot of work on steroid chemistry. There's a lot of recent COVID times, steroids only support helped us. The steroid treatment only taken place so much because of the throat related, lungs related, and all steroids only. So lot of work pharmaceutical taken place. So these all industry people used to use this single amino acid catalyzed reaction. No need to use the enzymes and antibodies and all. Single amino acid is the nature produce. How the nature will produce the proline? This is single amino acid. Any student can know that this amino acid is the proline, natural amino acid. Lot of chicken shops are there, right? Lot of chicken shop wastage and all. Entire waste of the chicken you can take and go for the cutting the peptide, because a lot of will be there. Especially egg and chicken waste and all. You go and put into the degradation of the peptide. All degradation of the peptide, when you cut it, more alcohol will be there in that polymer, chicken-based polymer, especially leather, egg and all. You go for the removing the entire one, and very good amount of the alcohol can extract from the wastage. So from that we will buy the from the whatever the companies. So nature only will give back. Well, this is the way when we study BSc, MSc, and all, before going to PhD, we have to understand the Gurudharma, where is the real problems are there. Should not work for the this purpose, purpose, like a publication purpose or name purpose and award purpose. Really, we should see the where is the problem. And he is the one, he looks like a real, the Valmiki, the way he described the Ram, right? I feel like a that much height and extraordinary personality. When I go and stand to him, I have to watch him like, oh, that's very, so nice person. So he is the one they can really challenge for the 1970 what Ajas Paris they developed golden catalyzed reaction mechanism did not understand, right? Now he is the one who is understands antibody catalysis. In antibody catalysis, lysine amino acid, in this reaction, amino acid, he thought that mechanism is same mechanism. And he tried to explain about the same experiment with the same substrate, antibody alcohol, he conducted the experiment. He understood that mechanism is going very similar manner, and they published in March 1999. He is the Benjamin List. We see sometime luck how it will be. Luck also sometimes very required. As students, you watch carefully. He is the Benjamin List from Germany. He working as a postdoc in his laboratory. He is the learner is the Spitz director. He is the at that time he become a young professor. And they published the correlation of these two. After the correlation of the subject, in the same next month, they thought that in the previously 1970s only worked on intramolecular reaction. Intramolecular kinetics, thermodynamics are a bit past. But what about the intermolecular? If intermolecular also reaction goes same manner, then we can understand the mechanism of this reaction. They performed the intermolecular version of the aldehyde acetone. Chemistry went very nicely. They able to achieve. They got high selectivity, enhanced selectivity, and they explained the reaction mechanism. Previously, they did not explain, right? Now, Carlos Barbas explained very nicely. This is the way this person will react with this ketone. Very nice. This is the nucleophile. This is the electrophile. Will form imine and enamine. And now this aldehyde goes very close to the enamine. This enamine can come backside of the enamine or front side related to the acid. But this acid is dictating. That is the what is the close interaction. So this acid is asking carbonyl come same my side so that I can activate by hydrogen bonding. And this hydrogen bonding is happening, this big electrophilic increase at carbonyl, and the CC bond formation will take place. That is a very good facial selective. Then they wrote the excellent paper and all. And now here drama happened. Here is the Benjamin List, right? His star came. These two people did not get the star, and he got the star. Within 2 months. Hey guys, understand it? Within 2 months, he became an assistant professor. No, he is from Germany. His auntie is the Nobel laureate, and he want to get the Nobel Prize in the antibodies, and able to get very extraordinarily in overnight. He become assistant professor. His brain is extraordinary brain. He understands this work will be going to be beautiful manner. Anyway, Carlos Barros already well known for the antibody catalysis. He overnight became assistant professor. He got the star author. He submitted the paper without getting to these two people. Then within 1 month, the paper accepted, published. After that, get to know what happened. Then, very nice paper. Then he became assistant professor in the scripts, and professor started working. At that time, I completed my PhD. Then I applied to him, and he called me immediately come and join. Then I replaced his bench. He went to other building. Then I went and joined the same bench as a postdoc. So in the same 2002, one of the beautiful reaction is like a manic reaction. Even our entire our globe, manic reaction very important. If you want to prepare amines, amino acids, manic reaction, very important. This is the one. So this is the ketone, oleate, and this is the imine. Same L-proline able to catalyze the manic reaction. Ketone able to catalyze manic reaction. That year I joined 2002 January Sankranti Day, Makara Sankranti Day I joined to lab, and so many reporters came to Karla's Barba's lab and taking interview. One amino acid prepared another amino acid. That is the dialogue. One amino acid is preparing the other so many number of amino acids with the same selectivity. We don't need peptides. We don't need antibodies. We don't need enzymes. Only one amino acid able to enough. So that is the way is extraordinary manner demonstrated. And he is from the Caltech, California Institute of Technology, just Los Angeles, 200 kilometers from the San Diego. He got the inspiration from the Carla's work, and he started working on same simple amine catalyzed Dinsard reaction. Up to before the Dinsard reaction means thermal reaction. You have to put more than temperature, for a CBS reagent, so much Changama is there. But he made simplification that this catalase will react with this one, will form imine like that, and this is the diene and this is the dienophile. I hope you guys know Dielsard reaction. 4 plus 2 cycloaddition reaction. 4 plus 2 cycloaddition is the noble reaction and will form the atom economic reaction. And this is the dienophile and this is the diene. Exclusively, selectively, it comes from the downside, we form this cycloadduct with more than 94% enantiomer action. This is the one reaction. And this is the way it's going on oral. See, where is the enzyme and how developed? Then after my master's from the University of Hyderabad, I am so fashionable in organic chemistry. I want to understand the more synthetic. As I am also the carpenter son from the article. I learned construction from my father. So my father used to do carpenter work, blacksmith, agricultural work, and all. But I am so fashionable in full construction concept. So I want to do molecular small construction. Then I joined with him. Sri Krishna is my supervisor in Bangalore IISc. Then I had nearly 15 molecule photosynthesis I did. Almost 50 steps, 15 steps, 15 molecule I have done photosynthesis. I got experience because that is more important. You have to get more experience with synthesis and all. So I got experience and all. Then I joined 2002 January with his laboratory. Very, he myself is from IICT. She is from the Tamil Nadu. She is assistant professor from Japan. He is the postdoc. He is assistant professor from Japan. He is another postdoc. Very few number, but we did the decent job. And this is the reaction I worked in Carla's Barba's lab, and that has become a name reaction that is called Barba's cycloaddition reaction. Then I started my work in at 1st January 2005. Teachers support. That's what people have expected this Ramapata to. I think once people should plan and see the pillars. That's form very good pillars. But the subject also you need quality pillars, especially catalysis. We have a very these two only not previously. Before we enter the catalysis, before 2020, only these two catalysis, metal catalysis is there, biocatalysis. This struggle so much. But after 2020, after 2000, especially after 2000, and started this two, we feel proudly to express that we able to develop the organocatalysis. My lab exclusively developed the supramonk organocatalysis. How important is supramonk organocatalysis? Entire one pillar we constructed for the catalysis purpose. How important for the developing industry point of view. That few reactions I will have. Actually, that's what you people should know, especially students who go more library. Libraries nowadays coming to your pocket because already my entire library pocket is there. You won't go through problem. It's there with me only. I will see tomorrow. I will see day after tomorrow. I will see next month. It's gone. The semester is over. Entire year also over, but you won't see that. You should go to the library. Hard copy is very important. So when we see the library, go to see literature and all, these all are natural products. These all are natural products. This is another set of natural products. Some of the drugs are there, some of the market. No, sometimes when you go to the doctor or somewhere, when you give injection or tablet, you should see what is that material. how it is coming, material, any whatever we use from top to bottom, we make this material from where it is, how it is coming. So you'll understand how to prepare them. This all will come from the starting material. But how they know, how they prepare starting material means you need cages, not even grams. But how to prepare those cages? These are the one exist. This is the classical method. In the laboratory, we have alkylation. This one you will get from the Claisen condensation, from the Daikin. You will get the cyclic. Now in the classical mode, when we do alkylation, alkali halide base, you can form C alkylation, you can form O alkylation. Both will form. According to HSAB principle, hard, soft, acid base theory. Hard, soft, acid base, HSAB. Only soft electrophile like a methyl iodide, allyl bromide, propyl bromide, benzyl bromide. The soft electrophiles will go nearly 60% there. Remaining hard electrophiles more will go to O. O is the hard nucleophile. Will go more hard. This is an unwanted reaction. This is a byproduct. We don't need that. So that is the reason the Louis Packard is from USA. He used to work on more application of this material. He went on 3-step mode. This is the one aldehyde and mercaptan, silica. He mixed these three. He got this one. If you ask me one question, without mercaptan, these two, you will get unwanted, useless compound will get that. Because this and this will form olefination. One more molecule will go react with that olefin will form the bisadec because they are highly reactive. To stop this one, he added mercaptan. Now he will randomly do desulfurization of this one, sulfur carbon bond breakage. Then he will get the alkylation. Now use this one on further application. In this reaction, drawback is there. What is the drawback? If vinyl mercaptan will give very ugly smell. Many girls know sometimes why you won't go to chemist lab. You normally go to some life science labs because the chemist, a lot of smell will come, corrosive and all issues are. That's why you won't show much interest. That is the way we want to develop the tools that we should become very friendly, bio-friendly, a sustainable manner. So we cannot use the large scale. This another one is the raninical. Raninical also small scale is okay. If you take the large scale, it may catch fire. Raninical with oxygen will catch fire because the decantation is difficult in large scale. So this is only academic reaction, not a industry reaction. Then how to make? This is the one recently, 2012, the Broadshop from Germany, he developed this reaction. This you can get from the bridge reduction, use the traceable lithium, HMTA, THF, alkali halide, and decarbonation. Chemistry went to around 70%. But here, traceable lithium handling is difficult. Even I cannot allow my student to use traceable lithium. Traceable lithium is highly catching, fire catching material. Even one day accident happened in USA. One laboratory, one girl using the traceable lithium by mistakenly, by taking the syringe out, she did not make the pressure releasing and pressure reverse came and broken the needle and glass and entire needle fallen on the dress and bad luck she did not wait the apron 50% burn. 2 days she struggled with life and lost her. 2019, 1998 or something like that. Then USA laws are very strict. Then supervisor is the band for 10 years guiding the students. It is there, the entire story is there in chemical engineering. So that's why the traceable lithium is not easy to handle. So that is what chemistry. That's why we need to develop the real sustainable reagent. In my point of view, even farmer also can use the reaction in farming field. Some of the reaction farmer can generate in the farming field, just mix A plus B and you can get the material, quintas, and pass on to the field. So that much simplification we should do that. So keeping these drawbacks in the mind, and we came out in 2005. This is the reaction. We've taken the cyclic ketone, we've taken the aldehyde ketone, and this is the ancestor. Ancestor is the reagent which mimic the our body or plant body hydrogen source. Life science students are there, MSc students? MSc students. MSc లేదా మన బాడీలో ప్లాంట్ బాడీలో హైడ్రోజన్ సోర్స్ ఏంటిదే ఇప్పుడు హైడ్రోజన్ కావాలంటే మనకి ఎక్కడి నుంచి వస్తుంది? ఎనర్జీ. ఎలక్ట్రాన్స్ కావాలంటే ఎక్కడి నుంచి వస్తుంది? That is called NADPH. NADPH, nicotinamide adenine diphosphate. That is the coenzyme. That is the cofactor. That is the one of the beautiful in human body or plant body. That is the Watson will give. In that, key active site is the dihydropyridine. Pyridinium cation or dihydropyridine. That is the equilibrium. Dihydropyridine or pyridinium cation. This is our dihydropyridine. So organic chemist is the extraordinary carpenter. He will take the only important site. We don't need that much. That is exists for some other purpose. You have taken only that dihydropyridine. Now H minus goes, electrons goes, NH plus will come out. H plus from here, H minus from there. So H minus H plus H2, right? That is electron source. So now simple amino acid, this amino acid can condense between these two to form olefin, and that olefin have a lowest unoccupied molecular orbital, and this have a homo, highest occupied molecular orbital. From there, this orbital interaction, H minus goes as a nucleophile to attack on the olefin, and the double bond will reduce, H plus will come here, and pyridine will form, and the double bond will reduce. This entire one is happening in one pot, the same like in the plant or animal. So that's the way we design this reaction. Any solvent you can form, and you can get this A plus B plus C and simple amino acid as the catalyst, different solvent, any solvent, whatever you want, then we can get this one. And this is, we are working this reaction from 2005 onwards. So 20 years now, we develop this reaction. Every student over time will have a development of this reaction. One example I will tell you. This is the reaction. We want to introduce the proper side like this to that reaction. Why I need to introduce? You can see if the previous other scientists developed, they want to do this is a quintas available. If you want to add this one, got only 40%. Remaining is going unwanted. Only 42%, 29%. Struggling so much. This is the more designed one, able to get 99 because of spirits. Because always you cannot go design one, right? We want to go simple one. But application, you see, a lot of application in photosynthesis. People are compromising. That is the problem in chemistry. Chemistry, we only give a lot of life to the entire world because we prepared so many drugs, pharmaceutical material and all. But somehow we got it and we spoiled the environment. Lot of wastages. But we should cut down now. Hello. ఇదని చేయండి. ఎక్కడి నుంచో వచ్చాం హైదరాబాద్ నుంచి. మీరు మాట్లాడుతుందండి ఏం చెప్తున్నాం వినండి కొంచెం. So this is the lot of application, but with that this much drawbacks and this much negativity, somehow prepare that one and utilize and try to give the medicines to the world. But we understand this problem and be able to solve using this reaction. You can see A plus B plus C and 91% yield we got. Previously only 40% yield, right? And now 91%. That too with the Cron scale we perform 87% yield. You can see that reaction is starting time like that. After the end, when you add the water, entire byproduct all will go to there and your product will be like a solid. Just you can filter it. Any organic reaction, if you just filter it and wash it, by washing, filtering only, we'll get the pure compound. Really beautiful. Because there's no wastage. That's what we prepared, thanks to this reaction. So, like that, this is the one, another one. I hope girls like so much. What is this leaf? చెప్పగలరా ఈ లీఫ్ ఏంటిదో? వెల్ ఆ లీఫ్ ఏంటిదో చెప్పగలరా? గోరెంటాక్. గోరెంటాక్. మరుదాని ఫ్రమ్ తమిళనాడు సైడ్ మరుదాని, తెలుగు గోరెంటాకు. గోరెంటాక్ లో ఉన్నటువంటి కీ ఇంగ్రీడియంట్ దిస్ ఇస్ ద మాలిక్యూల్ లాసో. I will ask you something. You know, normally we have a great stories from మన నాన్నమ్మలు అమ్మమ్మలు చెప్తారు, ఎస్పెషల్లీ అమ్మాయిలకు. గోరెంటాకు చేతికి పెడితే మంచి కలరు మంచిగా వస్తే మంచి మొగుడు వస్తానంటారు కదా. ఈ మంచి మొగుడు వస్తుంది ఈ కలర్ ఏమైనా దానికి ఏమైనా శాస్త్రం ఉందా లేక మా కాకమ్మ ఉందా? వాట్ ఈస్ దట్ బిహైండ్? ఎస్, ఇస్ ఎక్స్ట్రాడినరీ సైన్స్ ఇస్ దేర్ బిహైండ్ దట్. అందుకనే మన పెద్దవాళ్ళు చెప్పేది శ్రద్ధగా వినాలి. దాని వెనక చాలా సైన్స్ ఉంటుంది. అది గుర్తుపడేయకూడదు. బికాస్ దే ఆర్ ఎంటైర్ సైన్స్ దే పుట్ ఇన్ ద సింపుల్ వర్డ్స్. That they are really pioneers, they are real great scientists. They won't tell posing so much science. Entire science, they will make it simple manner. This is the way you follow. They will tell like that. But we won't understand, we pose so much. So here, this is the molecule lactone is the key ingredient in that whatever the leaf powder is there, right? If you take the bed, you put on the skin. Now this fellow will on the skin surface chemistry take place. How the surface chemistry take place? In our skin, all the amino acids, amino acid contain peptides. In the amino acids, one lysine amino acid, serine amino acid, cysteine amino acid, tyrosine amino acid. These amino acids have a functional group. What kind of? Pre-NH2, pre-OH, pre-SH. This pre-SH, pre-NH2, pre-OH containing amino acid. How many? Cysteine, serine, lysine. These amino acid containing one you have, and that functional group will react here, will go oxamical or thiamical or azamical reaction, will attack because of carbonate. This water relation takes place. This entire chromophore will be connected to your skin through covalent bond. Now this entire chromophore is connected to your skin. That is the chromophore, right? Now here Raman chemistry. See Raman explain nicely. Because this is a chromophore, sunlight fall on you, some amount will take this ring and some amount will release. Whatever the release is, you will see the color. Just come box it very nicely. Now, what is the relation of this one to the coming the great aspect? Now, this molecule, if you have a nice packing in your form or wherever skin and all, is there very intense manner is there, very intense is there absorbed nicely surface, you will get a very intense color. Intense color means compound has to absorb very nicely under the skin. Means these lysine, serine, cysteine containing amino acid and peptides more. They are more on your skin, they absorb more on through covalent bond. If they are more are there, then what will happen? Your skin always will be moisture free because of the functional group, always will be little bit from the weather and all will take the water molecules and all will keep your won't be dry. Your skin won't be dry, always will be active more. Your skin is very active, you look better. You look more healthy and more happy manner, very reactive, active skin. When you look better, everyone loves. That is the meaning of behind the great science. So I am more fashionable on this lasso, and when I see chemistry point of view, carbonyl, double bond, linolate, then we applied our chemistry, introduced alkyl group. We developed not only this lot of medicines are there behind this actually, a lot of medicines actually. They all are antibiotics. These all are antibiotics and prepared from using lasso. So we had a very extraordinary aesthetic reaction based on the design. Not understand this. I don't want to go deeply inside. Who are interested, they can go to our website and get this better. And we explain very nicely how simple amino acid is just hydrogen bonding. This is the molecule from alkaline, vinyl alkaline. Vinyl alkaline we modified, we get the catalyst, and that catalyst made this reaction to make the methyl. We are working presently to one of these molecules in water synthesis. We explain the mechanism. We explain the mechanism thoroughly by X-ray crystallography, computational things we apply, and we explain thoroughly this mechanism, how whether it's coming this methyl backside or front side. We explain thoroughly. Like that, develop this lasso in more reaction. You can see we use the benzene chemistry to make this kind of molecule. Those are very important molecules. You can see how application. Based on application, we design the reaction, and we are making one of these molecules in water synthesis. And we see that 1, 2, 4, 5 reagents we use and be able to make five reactions in one part to make the high strain molecule. Drawing of the structure. Rather, when we have any fraction, we can have a complex structure. My fraction is I want to construct the molecule with high functional flow such a way that more complex system has to come a bit more. How much time take it? So when you design the reaction, you can say substrate. Come on, start. The reaction. We had another interesting aesthetic reaction. This is what important. Students, without this catalyst, if we mix these two, salt will form. Later I will ask one question. You ask question me or I will ask you to answer. Without this catalyst, if you mix this and this, you will get this product, no E. No catalyst, no E, right? At room temperature. But at same room temperature, if you add the 30 mole % of this catalyst, same reaction goes and you will get the 99% single enantiomer. Let's understanding. Both are forming the same path without catalyst. Product is forming within 2 hours, 99% yield, but 0% yield. But if you add this catalyst 30 mole %, then you'll get the same 94% yield up to and single enantiomer. That is the beauty of the reaction. Because catalyst is controlling completely to go in only one path, a selective manner. But if you take the 5 mole %, E go down. 20 mole % E go down. But 30 mole % is enough to control every part of the reaction to go in selective manner. And that actually later we can ask you a question why, what, how it will go. Well, this is also we explained, and I'm very happy that because the two people like so much of Gorenta, entire Gorenta is related to highlight how the Telangana area, especially South India, entire South India, there are a lot of Gorenta. Yeah, I like that. How much time I have now? Another minutes? 20 minutes are left. 6, 7. So, especially in the life science, enzymes required, no matter, enzymes require only parts per million or parts per billion level. Because the very small amount, that entire life will be input for the enzyme. Whatever the small enzyme engage to form, it will be stay like that. Nothing will happen. That's why the engage to deep value, should be extraordinary. Whatever the product forms, the particular age, that will be input for throughout your life. You have to keep very proper manner of health. So in the organic mix also we are working on not to load so much catalyst. Can we do the organic reaction by parts per million level? So we able to develop this reaction. You can say 500 ppm we use the catalyst and we able to develop a simple enantiomer, simple reaction. We are working on more of the complete limiting the enzyme with a simple manner on organic level. Parts per million. Well, to apply this last code in different reactions, all are natural products. All natural products in these they have done by 50 steps. 20 steps. From morning to evening, I used to call up. End of the evening, I used to get like factoring time because there's so much standing and doing reaction. All expensive. What happened? Yes, sir. Then after my PhD, I thought that this much back pain and all is not correct. Okay, we need to develop some different tools. That's the one. From your struggle, real, with some real tools. And with all we have done, entire one, you can see that. We see the substrate, this is the one substrate, we start the catalyst, then we go in one part to construct a variety of the tricyclic system. We mix it with and get another natural product, this two, and you got the entire backbone of the natural product. Here, really, example, single enantiomer, single diastereomer, single product selected out of 3, but only 1. So thanks to the natural product. Now we are working on enantiomer selection more than 3. So that's the way. So early you struggle, no problem. But try to understand about the betterment of the outcome of the problem. Actually, that is the way. There is much time to my masters teachers and all. When I'm doing my masters, more than there are internationally sounded teachers. Passion is very important to get into that. So my passion is I want to have some name reaction from this country. So people started using this reaction. మనకి తెలుగులో ఒక సామెత ఉంది, కాకి పిల్ల కాకి మూత. Hey guys, కాకి పిల్ల కాకి మూత అంటారు చూసావా? మన రియాక్షన్స్ మనకు బాగానే ఉంటాయి, మన వర్క్ మనకు బాగానే ఉంటుంది, మరి పక్క వాళ్ళకి ఎలా ఉంది, పక్క సైంటిస్టులు పక్క దేశం వాళ్ళు ఎలా అంటున్నారు కూడా ఇంపార్టెంట్. So others they started using many people in photosynthesis, reaction mechanism, and material chemistry. Material chemists also started using this reaction. Very happy when people started calling this as a name reaction from the India. Happy to share with you that. And this is the way. This is the way 2021 Nobel Prize came for this organocatalysis within 20 years. 2000 started, 2021 came Nobel Prize. You see that it's a postdoc, right? He's the postdoc. He got the Nobel. Other person from the Caltech he got. Main person is missing there. Carlos Barbas is missing. That's the what. The health is very important. It's a bad luck that he got the cancer. He got the very, very different cancer. And the young age of 50, he passed away. And he has the poor companies. He has the heavy antibodies. Extraordinary doctors are available to bring him. A lot of money is there. Everything is there. But nothing is helped him to save another few more years. That otherwise we should have shared their 50%. These two people got the 50% share. So that's what I will tell you. Health, keeping good health is very, very, very important. Even though you are great scientist, even though a lot of everything is there, but once you lost the health, nothing will be helpful. Yes. Yeah, always I feel bad that my supervisor is not here. Yeah, otherwise should have been the Nobel family. So you should have shared that. Well, this is the other reaction. That small ring, very, very small ring. Because when you go to this is the viral fevers, right? This viral fevers time, when you go to hospital, when you ask the doctor, when you give an injection, you see what kind of injection, one first dose, fever is coming down, not coming one day, the second day, another some other drug. If the fever come down, okay. If it's not coming, you'll go to third dose, third different one. In third one will be there combination of these two fellows will be there. These two fellows will be joining along with the penicillin. Otherwise, it's very difficult without these two people. So that much become. So click reaction become very, very important because it is bacteria, virus, too much is dominating. It is getting its own sustainability. It's sustained that point of very dangerous. So it's sustaining so much. That is the reason we need that different drugs. And this subject really helped. And this is the way these people develop this reaction. And we understand the subject, and we came out with metal-free approach from University of Hyderabad, and we developed this reaction. When I'm free time, I will come and free time to the MSc students. I'll talk one evening class. We'll have more free time. So now I will leave it here. We developed this all reaction. I'm happy that this is also called as the name reaction from the University of Hyderabad School of Chemistry. This is the what is the supramolecular catalysis. No, sometimes many people from the farmer family, right? Farmer family అయినప్పుడు సాయంత్రాలు చూస్తారు మంచిగా వ్యవసాయదారులు చిన్న చిన్న నారు ఉంటుంది కదా, ఏది తాటి చెట్టు నారో లేకపోతే జనప నారో ఏదో ఒక్కొక్క లేయర్ తీస్తారు. One layer, two layer, three layer, the weak interaction, one small interaction is very easy to break it. But అలాంటి small interaction ఒక 10 ఒక 5 6 ఎక్కువ lines that the cluster will become very strong. The cluster can make miracles. So that is the main inner piece of that. Then we made that supermod analysis. Make the high answer selectivity. We explain all online and online mass, etc. How the cluster is formed. There is a 18 number cluster, 19 number cluster. We understood here and now looking at this country. Very fashionable in Telugu poetry. Sometimes when I get a good result, I'll try to make the cover. I'll try to make the cover picture from my our Mahabharata, Ramayana, like that. I'll take the story. I'll make the cover picture. So like this, when we read the Mahabharata, we'll understand the entire story when you write. When you read completely, the Vyas we wrote, Arjuna, Krishna, the friendship, the relation, understanding, the cooperation, the coordination, everything is excellent. So that is a very important lesson for us. So in the same way, in chemistry, catalyst substrate interactions are excellent. Then you can do miracle. That is the what they made the cover picture on that. And the my garden picture, I like very much this flower. Taken one flower and made the cover picture of that. And this is also another interesting one. The story I will tell later. I don't have time to explain. But the same way, according to me, whatever I read Mahabharata, for me, I think Arjuna is the best student. I think. Why best student? So when he is in, always we should be ready to learn new things. That's what I also inspired from my professor teacher. Always you get the new techniques, new lens, you learn and you teach so many new things, computational chemistry, material chemistry, lot. But no, sometimes we'll after become a professor, no, I'm already professor, no, I don't need to learn new things. Even teaching also people get a lot of hangama create. No, I don't need to take the class like that. But that's not correct. It's always should be ready to explore some new thing and teach the students and give the energy to them. So Arjuna in middle of the 18 days war, opponents are very great strong people. You need to get the new weapon. The Krishna tells, can you get this weapon tomorrow? 14th day is a very heavy day, extraordinary. Somehow you lost that weapon. Can you go and learn and get it? Okay. Then he goes midnight and sit calmly. Again, learn the password, everything, how to use it. Nowadays, we use as a password and all. Sometimes he forgot the password. Then again he has to go and sit calmly and learn everything and all. Again, come back as I got it. I'm ready. So should be always ready to learn. So I thought high selective person. If you have a highly selective and extraordinary in the work, then always you will be there appreciation from the people like that. They will have garland ready to appreciate. It's like way Draupadi appreciated always. So it's another one I like very much is from Ramayana. I should read Ramayana. I should read Ramayana, Mahabharata, all. Be really grateful to our ancestors, the way they wrote extraordinary books. See here, extraordinary teamwork. No, only two brothers started walking, and suddenly somehow, his lady, somebody came and taken away, and he don't know anyone. Vanavasam, right? You cannot take the back, Bharatu, whatever the army cannot take because he's in the Vanavasam, because you cannot ask anything from that. But somehow he has to take people help. Then he able to take the Vanvas help and all, then we constructed. This is first bridge because we have a lot of bridge constructions in our laboratory. But this is the social bridge construction. First bridge construction, very nicely. But the student like him, if he's there, that laboratory or that country, how extraordinary it will be. That's what I believe. That's the way I made the cover picture. Always I feel like it's a great to associate with kind of people around. Then automatically your work, everything will be great. Yes. So I'm very much thankful. This is the what is recently we had a cover picture like Samudra Manthan. Samudra Manthan, you should read the story. When you read the story, you will understand. చిన్న చిన్న కష్టాలు వచ్చినా ఏది వంగకుండా బెదరకుండా how to make sustainable స్థిరంగా మీ ఇచ్చిన లెక్చర్ కు అది సెమినార్ కి స్థిరం ఎలా ఉండాలి స్థిరంగా అన్నది చెప్తారు సముద్రం అంతా I read n number of times story will tell you why you should become a scientist. I'm very much thankful to my all the PhD students and postdocs and my collaborators. Without finance support we cannot do anything, and thank you very much.
Sir, thank you. Thank you is not enough because Sir was covered so many things. I brief out just listen carefully. Just I will read out how many things Sir was covered so far. It's a important things are asymmetric managed reactions, disorder reactions, and also first catalysis asymmetric reactions and metal-free enzymes in the catalysis and enolate aldol reactions and supramolecules in organic catalysis and dihydropyridine, how to use that and pour it up is a loss in it. And also Sir covered the catalysis of asymmetric synthesis and 7 benzo bicyclooctanes and medicinal importance of that octanes and multiple steps and 1/4 synthesis and click reactions and applications of the functionalized 1, 2, 3 triazoles. See, these are the ఒక లైఫ్ టైం కూడా సరిపోదు మనకు చెప్పడాలంటే ఇది కేవలం బుక్ లో ఉండి చదవడానికే మనకు చాలా గుర్తుంచుకోవడానికే టైం పడుతుంది. సో ఇటువంటి అన్ని కూడా ఎంతో కష్టపడితే కానీ ఎంతో హార్డ్ వర్క్ చేస్తే కానీ ఎంత కమిట్మెంట్ ఉంటే కానీ చేయలేము. ఒక కెమిస్ట్రీ పర్సన్ గా అది అర్థం అవ్వడానికే చాలా టైం పడుతుంది మన లైఫ్ టైం. ఒక చిన్న ఇన్నోవేటివ్ థింగ్ తయారు చేయాలి అంటే సో సార్ వాజ్ రియల్లీ డెడికేటెడ్ ఫర్ డూయింగ్ రీసెర్చ్ అండ్ ఎవ్రీథింగ్ కమిట్మెంట్ హార్డ్ వర్క్. It is a very big applause for him. Very and really I am very much happy for attending this session and we learn a lot sir from you and Telugulo kuda and son of soil. The most important thing is son of soil and is from NG college.
మాట్లాడతాను మీరు ఇచ్చిన ఈ గుడ్ వర్డ్స్ అన్ని will go to my
yes. It is both the professors will really have a good beginning of these 2 days seminars and because of their intellectual important things definitely we should because you are in a learning stage you keep on learn. Don't think about your age cannot be come into the picture and your sincerity, hard work, your commitment, your dedication towards the research is more important. Thank you sir, thank you so much for your contributing your the good words and good innovative things and we learn a lot and thank you for this session. Okay, thank over to the Sirisha ma'am.
Respected chairperson and distinguished speaker and other my dear participants, I would like to express my heartfelt gratitude to you, sir, for spending your most valuable time for a busy schedule to grace this event with inspiring words and facts of catalysts, especially the difference between the enzymes, metalloenzymes and non-metallic enzymes, that etc. Sir already informed about that briefly. And really, it's a wonderful session, sir. I'm very thankful to you to present these words. And this session further depend on our understanding the modern catalytics. And on behalf of the organizing committee and all the participants, I sincerely thanks and enlightening, inspiring presentation. And my gratitude also goes to the chairperson for guiding the proceedings gracefully and to all the participants for their enthusiastic engagement. And this session has truly horizons and reinforce the prevalent role and catalyst in advancing the science and technology. Thank you so much for giving this opportunity. Thank you, one and all.
I thank the team for the second session. Now it's time for lunch. There are few announcements. I request all the participants from various colleges to go for lunch near library. Lunch is provided. Cellar of the library. You can go there. And students, those who did not bring their lunch boxes, also are directed to go to the library. So you students, you will be assisted by a few volunteers. You can go in queue. And I request lunch committee so to take care of these things. So we'll meet again by 2:30 sharp. We'll be having technical sessions. So if you have any doubts also, you can have time of interaction at 2:30. So meet you at 2:30 p.m. Thank you.
రెండు కవర్ చేస్తే అట్లా టైం ఇది థింగ్స్ మా దగ్గర లేకపోతే అది ఏదో మనకి కదిలితే అది ఏదో వస్తుంది. చెప్పండి ఇది ఆబ్జెక్ట్ చేసి పాస్ ఇది కాడేసి ఇది కరెక్ట్ అయి ఉందా? పాస్ చేయొచ్చా? ఒక పక్కది పాస్ రికార్డింగ్ స్టాపా ఏ స్టాప్ చేసి మళ్ళీ ఇక్కడ రెండు కంప్లీట్ చేద్దామా ఎట్లా బ్యాక్గ్రౌండ్ లో బ్రేక్ అని రావాలి పెట్టేసి ఏదైనా పెట్టు 230 అన్న సమస్యపోయినా నెట్ కావాలి మధ్యాహ్నం చెప్పు సరే కానీ ఇందులో వాట్సాప్ లాగినవా ఇందులో పంపించారంటే మళ్ళీ కష్టమైంది ఫస్ట్ జల్ల పెట్టా ఏది
University of Hyderabad. Dr. M. Tirmala Madam she is a HOD, Biochemistry, Mahatma Gandhi University. So, and I also request Shivrani Madam as a rapporteur. Shivrani Madam is HOD, Botany. Now I hand over these proceedings to Tirumala Madam. After presentations from the teachers, students, research scholars offline, then online presentations if there are any. You be ready. Those who are waiting online, you can raise your hand so that all of you, or we will make you co-host so that you can present online. Now I hand over this time to Tirumala Madam.
स्लाइड नहीं है ना, खाली मैं आपका पीडीएफ है, पीडीएफ पिक्चर में लेजर काम करता हूँ, लेजर काम पीडीएफ को ले जाना 50 देगा पीडीएफ की है, मैं चेंज करता हूँ, आप बोलते रहो मैं करते रहता हूँ. ఓకే పాయింటర్ ఏమొద్దులే ఇక్కడ పెట్టేసి ఓరా నిచ్చే కారా కాదు उधर दूर मत जाओ, उधर ही रास्ते चलो सर वाटर बैठा हम करते हैं.
Just Belisman adult. This Belisman adult will be treated with the so further this Belisman adult it will be converted into bromides in the presence of sulfuric acid and hydrochloric acid, and this is a overnight reaction. Okay, and we got two types of bromide, and here we are having a Belisman bromide. It will be combined with thiopyrimidine, and we got the respective thiopyrimidine derivatives. So nearly we have synthesized 7 Belisman bromide thiopyrimidine derivatives, and we have screened against antimicrobial activity. So before screening, we have gone for NMR. So if you look at the NMR, you can see here you are having so this is a structure, the chloro substituted structure, and here you are having 2 dimethyl pyrimidine, here methyl substance, you can see 2.33 chemical shift value, and here you are having a ester. The ester protons will be coming around 3.84 chemical shift value, and this is a 4.37, that is a CH2 protons, and you are having a here the olefinic proton, that is a around 6.67, and these are the aromatic, and this pyrimidine proton you can see around here 7.78. So this is a NMR which we have gone, and this is a C13. And next we have seen for antimicrobial activity, we have taken different strains both against gram-positive and gram-negative bacteria, Staphylococcus aureus, Bacillus subtilis, and gram-negative bacteria, Enterobacter aerogenus, E. coli. And we have used the two drugs, that is the ciprofloxacin, and for fungal antifungal activity, we have used the drug that is itraconazole. So all these are nothing but the zone of inhibition, which we have measured by taking as a standard drug in the market. So if you look at here, you can see this is the ciprofloxacin, which is showing a zone of inhibition against the bacteria, gram-positive and gram-negative. And here our compounds are there. And here the value will be a 14, and we have got the 15 and 16. That is, the zone of inhibition is good compared to the standard drug. And here you are having a itraconazole, that is a 2021, and this is the antifungal activity. We have taken the two strains, that is a Aspergillus niger and Candida albicans, and here we have got good to moderate activity. So this activity we have against gram-positive and gram-negative. So finally, I want to conclude that whatever the compounds we have shown, we have prepared very little compounds, 10 to 11 compounds, and screen against gram-positive, gram-negative, and antifungal activity. So they have shown good to remarkable activity. So by this, I'm going to conclude the presentation. Thank you so much for giving this opportunity. These are the compounds which we have prepared. These are the 105. All these are the very important we have prepared. These are the bromide. They are nothing but the benefit. The benefit all the substrates are prepared. So we prepare the different types of bromide and combine the thiopurine. So we have S, HBr, and all the compounds. It's a condensation reaction. Only few compounds we have prepared now, madam. If you still the research is going on, because only a small part we have given. If you prepare 50 to 60 scaffold, then we can go for broad range of activity. Another full means depending upon the amount, how much budget I am having. Based on that, I will continue my research. Okay. Thank you so much, ma'am.
I was just curious to know, like, what is the mechanistic understanding with respect to the mode of action? Because these antibiotics you are taking as a standard treatment, they have some mode of action. They kill the bacteria. What is supposed to be the mode of action? How they are going to kill the bacteria or the
Sir, they directly attack the cell wall. See, we are incorporating sulfur compounds. And also we are attaching both electron withdrawing and electron donating groups. If you look at the compound, look at the structure.
What do you mean like they found some kind of combination?
They were going to bind the bacterial strain, the DNA. Okay, the outermost cell which is there, it will going to bind, and it will going to inhibit its act. Means the growth will be controlled.
That's what I wanted to know. Like what kind of interaction could exist between a bacterial strain and your compound?
What should I tell? It's a maybe there is a sir, here we are having a fluorochloro. There is a hydrogen bonding interaction or ionic interaction.
Brain is
If you look at the structure of biological structure, the cell wall, the protein structure or the receptor structure, they should bind, a drug should bind to the receptor. So here the interaction may be a hydrogen bonding interaction. That's why we have chosen the fluoro group and the fluoro group. So they should have some electronegativity and they should bind the structure and inhibit.
What is the solubility of these compounds?
Solubility, they are soluble in a DMS process.
So do you think that causes some kind of toxicity?
Toxicity, it is not having that much.
DMSO is a pure organic solvent.
Yes.
So it is compound that is soluble in organic solvent. Do you think that it is bio-friendly system to see the solubility of the drug?
Most of the drug will be soluble in this solvent sources. Whatever we are taking the compound,
actually
a little bit toxicity will be there. I agree with you.
How your compounds overcome these solubilities? They are organic solvent soluble.
Sir, these compounds soluble in DMS. For these compounds also soluble in chloroform also. These compounds soluble in methanol also. They are having a very good solvent.
All are organic soluble.
All are organic. They are insoluble in water. Thank you.
Hello.
Dr. Venkatesh Padlu, sir.
Yes, sir. I am online.
You share the story. Sir, you can share the screen. Share the.
Okay.
You can start, sir.
Yeah. Just now I sent a request. Please accept for sharing the screen.
Okay, sir. Now you can check.
Good afternoon.
Okay, sir.
This is Dr. Y. Venkateswarlu, Associate Professor of Biotechnology. So presently working at Tara Government College, Sangareddy. So today's topic is on genetically modified crops for resilience to the climate change. This is my topic.
Wait a minute, sir.
The overall presentation, the executive summary of my presentation includes climate change intensifies droughts, floods, heat waves, and salinity stresses, and also pest pressures on agriculture. So these are all the various factors which influence the yield in the crop. So to overcome this one, GM, genetically modified crops, and gene-edited traits can enhance the resiliency by protecting the yield stability under stress. There are 4 important pathways are there. So these are the 4 key pathways. The first one is drought or heat tolerance. Second one is flood or submergence tolerance. Third one is salinity tolerance. Fourth one is pest or disease resistance. So these are the 4 key pathways through which we can build the resistance or resilience.
Sir, excuse me, sir. Sir, could you start from starting onwards? Why? Because we did not connected to projector right now. Just now we connected to projector. So start from starting onwards. After completion of your session, again you may host to back.
Okay, sure, sir.
Thank you.
Good afternoon. This is Dr. Y. Venkateswarlu, Associate Professor of Biotechnology from Tara Government College, Sangareddy. So today I am going to present on the topic genetically modified crops for resilience to the climate change. The overall presentation of my PowerPoint includes that climate change. What are the different climate change which intensifies, which affects the crop yields? That is nothing but droughts, floods, heat waves, salinity, and pests. So to overcome this one, genetically modified crops and gene-edited traits can enhance the resilience by protecting the yield stability under stress. There are 4 key pathways are involved to overcome these stresses. The first one is drought and heat tolerance by osmoprotectants, root architecture, or transcription factors. And the second one is flood or submergence tolerance genes. Then third one is salinity tolerance genes through ion homeostasis and transporters. And fourth one is pest and resistance genes by using BT technology or RNA interference or viral code proteins. So how these GM traits, that is genetically modified traits, could be built up? So this can be built up by using physiological mechanisms that includes osmotic adjustment and ROS scavenging, that is reactive oxygen species scavenging, and also membrane stability. This is one approach. Then improved root-to-root ratio and water use efficiency. So, second methodology includes molecular mechanisms. By using molecular biology approaches, also we can develop genetically modified crops. So those includes transcription factors for drought tolerance genes, that is DREB, CBF, and NFYB. These are the certain transcription factors, and transporters such as HKT and SOS for ion homeostasis, and aquaporin sleep proteins. These are all the molecular biologist approaches. Then another mechanism is protection mechanisms. So this is well known for all of us. That is by using BT rhizines from Bacillus thuringiensis, we can transfer transfer. So this can build up resistance against the lepidopteran pests. Then RNA interference, small interferon like RNAs also targets the specific pests and viruses. And stacked traits, that is 2 or more genes can be combined for developing the multi-stress environments. So this is another mapping climate stresses to engineering, that is drought, heat, flood, free heat, and salinity, biotic stresses. And this is in the tabular format. So drought, the benefit of this drought tolerance genes such as DRA, EB, CB, transcription factors enhances the rooting increases the roots. So thereby it will absorbs more amount of the water. And the advantage includes maintains the photosynthesis and gains set under water deficit conditions. Heat. So this can be developed by transferring the genes such as heat shock proteins and membrane lipid remodeling. So this protects the enzymes as well as the reproductive tissues under heat conditions. And also some flood tolerant genes such as sub1A and signaling and parenchyma formation. So this build ups the rapid recovery after submergence. Then similarly, next salinity tolerant genes such as HKT and SOC pathways by using modeling modifying these pathways, we can overcome the ionic balance and water stresses also. Then last one is biotic stresses such as BT gene and RNA interference. These are all reduces the crop loss and pesticide use. The case study, the first one is submergence tolerance rice. So rice is cultivated in wetland conditions. So during the submergence conditions, what happens? It drown. So to overcome this one, sub1A. So this is one of the gene is have tolerance in rice, which enables survival even after 10 to 14 days of the complete submergence. During the rainy days, what will happen? So these rice fields remain in under submerged conditions. This is the gene which can useful even after 10 to 14 days of the complete submergence also. And it is adopted widely in flood-prone regions, improves yield stability without yield penalty in normal seasons, and often combined with locally prepared varieties to ensure that farmer adoption. That is means we can transfer this gene into locally into our yeah. So overall, yeah. So this is overall. This is approximate share of the overall genetically modified crops. So among all these crops, insect resistance and herbicide resistance crops contribute more than the other drought and salinity related genes. Then this is the overall area under GM crops. So the area over last 15 years, the area has been increasing. And the summary includes GM crops plays a vital role in adapting the agriculture to changing the climate conditions, and also underscoring the need for integrated approaches combining the biotechnology policy and farmer engagement for sustainable agriculture development. Thank you, sir, for giving this opportunity. So if you have any questions,
please host back. इसमें कैसे करना PDF भी आदमी है राइट सर स्क्रीन कर बस इतना नहीं यहाँ बढ़ा सकते हैं बड़ा कर करो बड़ा कर ऐसा बोलूंगा मैं कर दो सेम कर लो नीचे कर दो बस एक्सपेरिमेंट बस पॉइंटर भी है बस चलो ये माइक ले लो वो बराबर नहीं होता वो करीब रख लो
Hello. Very good afternoon. My name is Sridhar Swami. I'm the student of Professor P.K. Sai Prakash and K.C. Rajanna, Department of Chemistry, Usmania University, Hyderabad. I'm a senior researcher around 12 years and I come forward with these two papers of my publications, completely relevant to the natural products and medicinal chemistry oriented. Finally, the natural products drugs are converted into a very suitable with the help of the chemical kinetics to understand its process, how it helps, and how we can orient the molecule and all. The majority of the aim is the forskolin is a diterpenoid. It's been isolated from natural plant material. Folius forskolin is a plant name. And, by using different types of reagents like hexavalent chlorium compounds, enhalosuccinamide, and sericum. These are the different three reagent groups which I have used to make this product into oxidation. The reason is to identify in which type of groups reagent will more actively participate the oxidation and benefits of the reagents which will act upon very accurately. The correlation in between what type of reagents would be the more benefit of in oxidation in very efficient. And overall, by having this kind of studies, comparative study, I come across that conclusively the reaction mechanism also in variations. Either may be a hydride transfer, either may be a hydrogen bromide transfer in halosuccinamides, in chlorochromate compounds, how it has been either single electron transfer or double electron transfer. This is what my ultimate aim of this topic. So this is the structure of Folius forskolin. It is a major aim is it is having tri-alcoholic functional groups on 6th position and 7th position and 10th. Whereas the 6th and 7th will be in axial positions. These two are secondary alcohols. The secondary alcohols is converted into ketones by using different reagents. That is what I have done. So these are the different comparative studies. It's completely done with conventional spectroscopy method by using simple spectroscopy, UV spectroscopy, and iodometric writing. These are all different conditions I have done by using the temperature variations and acid variations and solvent variations. In these three comparative studies, what has been confirmed that by following the temperature variations, I found that the temperature and its rate of reaction and its activation energy and its delta H and as a enthalpy and entropy based upon the entropy and energy of activation out of these comparative reagents right from the fluorochromates, PCC, QC. In that the PCC has very lower in enthalpy as an electron activation energy depends. The majority of the reaction is come across in PCC. So these are the one of the referencing graphs where that result communicated here. These are the comparative results from imidazole chlorochromate, marcolin chlorochromate, and quinoline chlorochromate, and pyridinium chlorochromate. Why these are all very straightforward passing through origin indicates that it is following the pseudo first order rate conditions. It defines here there is a relation between temperature as increasing the rate constant. Rate is directly proportional to temperature increase. So this is the one of the this is the Kelvin-Gibbs temperature. So with this we can identify electron activation energy. In overall comparative study, what is the outcome of from this is so to distinguish what kind of the involvement of either anion or cation is involved during the reaction, which has been found based upon the earlier results from this. Because all are in positive slope when we look into this. This positive slope, which will indicate us there is an anion involvement in the region. So if we go to with this, here we can go. If we take pyridinium dichromate, this is the step when we overall conclusively in our reaction. This is our participated associate reaction as an active ingredient in this commodity. So finally, based upon the electron activation energy is a comparative steady table. I have this is the acid variation table. How it's keep on increasing the acid, the rate of reaction also is in. But when come across with this solvent, when you are increasing the solvent, there must be a reaction either has to increase, either has to decrease. But here one drawback that what we have observed, the solvent what I am using, it is creating the barrier in between the reactant molecules comparatively it not easily involved in the reaction, which is like lipid bilayer structure is forming. So it is a permeability has to increase, but it is decreased here. So these are all the chemical. This is the mechanism that what I have discussed here. Here, first in the pyridinium chlorochromate in the presence of perchloric acid, this is the active molecule where it will make the molecule functional group into make the covalent bond, and where it generates the loss of electrons or in terms of protons in H plus ion. So finally, it will make the our finalized tri-ketonic substance of phosphorus has been received. So this is the mechanism based upon the chemical kinetic cycle. In this particular paper, discussed the comparative study in between the original phosphorin molecule and after modification. What are its ADMET properties also has been discussed. So it has the new inventive material that it could be utilizable as bioavailability is much more as compared to with the original phosphor. Okay. This is the table that will shows here the comparative study. These are all the properties. So this is the original molecule and this is the modified product. The outcome from this completely will relevant to the whatever the drug I have prepared is, it will involve or evolve its bioavailability in terms of specific cancer or anything like cancer. First publication. The first paper was completely with 3 different types of reagents mechanism as discussed, whereas it is the second one. In this abstract also it is for bipyridyl complex. So far we have studied iron and phenolphthalein acts as inorganic molecules, but it can be used as a complex materials for the oxidation material also. So this is what the complex I have prepared. Iron 10 1 comma 10 phenolphthalein as a complex material. This complex has been utilized for the oxidation. The same molecule I have taken different types of reagent comparative study. So this is what I have obtained, increasing of temperature. So this out of from this, so this is the one the mechanism where the iron have one extra feasibility. Either it may be having use upon 2 electrons or 3 electrons. Sometimes it may reach up to 6 or 7 also. Depends upon the conditions. So to avoid that one is maintaining of different conditions and temperature stability. So we have achieved this complex where it is been acting as using up of electrons. So this and our abstract which I have published here is a comparative study. Both are all the same, but the variation of this 1 comma 10 phenolphthalein to alpha bipyridine. The superior one is alpha bipyridine. That is only the one objective of this comparison. After this, what I'm going to do in the future, this particular molecule has been going to tested in terms of molecular hardening and dynamic studies to understand what kind of protein efficiency can work and could be an achievable target for DDR4 protein or any other one in the metabolic disorders or weakness. Thank you for patience.
And can you please explain in a simple manner that how did you get this molecule from the plant and the methodology used to analyze this using UV spectrum and the nanometers?
Basically, this compound is natural product. There is a separate procedure because of my earlier 5 years of time period in to isolate this product. First, you can take the plant material outside of the environment, hide into a shade place, without having to understand the primary source of this particular machinery. Powder, after powder, you have to make exact ethanol extract or ethanol extract has to be separate chemical system, either chloroplast or chloroplast. Finally, the only part is into compound, not original. After taking this root compound, with the application column, along with this root compound, we get so many different types of molecules, not only out of that, which is more interested in peculiarly because others are in very less percentage as compared to the out of 10 kgs of fruit sample, we only get 700 grams of
10 kg of this
fruit
molecule.
sample. 10 kgs of
How many plants do you need?
Sometimes it is tropical planting, only grown in India, some countries of India. Usually in Tamil Nadu, it will be grown as a crop product. It is susceptible to electricity and all. America, we have been setting a tablets. By this, only the ethanol has a group to include the product. 40% ethanol and DCL will be the elevated product. Post calling is not able to distinguish with our right. We need a car and as well as the required password of but based upon the attraction function are converted that 72 ppm, whatever the peak information directly where that you want to immediate that C6 times C10 start from
Throw your light on methodology used in UV and the nanometers.
UV spectrum, different characteristics. First of all, before making this compound to readable in a UV spectrum, because it is not readable. So what we have developed using the different organic substances, oxygen material is giving as a coloring to substance of this medium that water. Its phosphor is not able to dissolve in water. So the suitable solvent has not and dilate directly. Okay, I have usually used filters.
Yeah, quickly, I have two questions. How do you ascertain the purity of the compound you have isolated? How do you maintain the purity? The second one is you were talking something about the bioavailability of the compound. You said So can you just explain how it is enhancing the bioavailability and how you maintain your purity during the isolation process?
Isolation, pure compounds are already available in the market. Whereas we have after isolation, there are different methods. If we have used the chloroform to isolate this particular molecule, it will become into a crystals. So crystallized phosphorus will have the purity will be very high unless it is a powder form. Second one is bioavailability. It depends upon chosen results what it is obtained from the area properties. Second of all, the separate barrier and all these things. And when it was discovered, newly modified product. Because it has this nitrogen function, which is very less efficient in protein extraction technology. Then after converting into ketones, it has a higher tendency to interact with protein. Less nitrogen molecular interactions. Just the hydrogen interaction.
Thank you. Thank you. This is the end of the presentations. If there are any online presenters, no. Okay. If there are any, tomorrow morning 9:30 online presentations will be there 9:30 to 10 o'clock. So be ready at that time. Rest of the presenters. Tomorrow also there is a technical session. Okay. So tomorrow 9:30 it starts with the presentations, online presentations first, then offline presentations. I request the participants, those who are attending online, to present, to post your PPTs to the given mobile number or in the group, so that your PPTs may be loaded in the laptop. We'll continue the technical sessions. Now, the last session of the day, I invite dignitaries once again, chairman of this session, Tirumala Madam, and resource person, Shamlal sir. Okay, I hand over this time to Tirumala Madam. So we have 1 hour time, sir. We have 1 hour time. So we can take 45 minutes of session and maybe 15 minutes you can give for question and answers. Hand over this time to Madam.
Good afternoon, one and all. I am Dr. M. Tirumala, Assistant Professor, Head Department of Biochemistry, Mahatma Gandhi University. First of all, I would like to thank convener Dr. M. Anil Kumar, Assistant Professor of Chemistry, co-convener Dr. B. Anil Kumar, Assistant Professor of Chemistry. I also thank Mr. B. Nagaraju, Assistant Professor of Microbiology, and organizing secretary of this two-day national seminar on sustainable development goals, the role of life sciences. I especially thank Dr. S. Upender, Principal NG College, Nalgonda, for making me part of this national seminar. Coming to this plenary session, our resource person is Dr. Shamlal sir, Associate Professor, DBT Innovative Young Biotechnologist Fellow, Department of Animal Biology, School of Life Sciences, University of Hyderabad, Hyderabad. Sir will deliver a talk for 1 hour. Before listening to his talk, I will introduce resource person to the audience. Dr. Shamlal did his BSc from Usmania University in Biotech Department in 2007, MSc Biochemistry from HCU in 2009, PhD Biochemistry from Banaras Hindu University in 2017. Coming to his professional experience, Sir has worked as Scientist B, Scientist C, Scientist D at Infectious Disease Biology Lab, Chemical Biology Unit, Institute of Nanoscience and Technology at Mohali, Punjab, India, since 2015 to 2023. From October 2023 onwards, Dr. Shamlal is working as Associate Professor, Department of Animal Biology, School of Life Sciences, University of Hyderabad. Sir is awarded with Hargobind Khorana Innovative Young Biotechnologist Award for 2023 to 24 DBT Government of India, Early Career Research Award in 2016 DST Government of India, ICMR International Travel Award in 2014, Young Investigator Award from Bill and Melinda Gates Foundation in 2015, ICGB Travel Grant in 2016. Sir has 40 national and international publications to his credit. Sir has published 1 conference paper and 8 book chapters too. 4 students were awarded PhD degrees under his guidance and 2 more students are pursuing for their doctoral degree. After joining University of Hyderabad, Sir has successfully completed 3 extramural projects sponsored by DBT with 61.5 lakhs, ICMR with 58 lakhs and DST 47.1 lakhs as principal investigator. Sir has one intramural grant too, which is sponsored by University of Hyderabad with 20 lakhs. Before joining University of Hyderabad, Sir has completed 2 projects sponsored by DST with 49.4.5 lakhs as principal investigator, DBT with 99 lakhs as co-PI. With this short introduction, now I invite Dr. Shamlal to deliver his talk. Thank you.
Thank you. Yes. Yes. Am I audible? Yes. Yes. Yeah, thank you. Thank you one and all, and especially the organizers who sent their kind invitation for this spectacular program. And actually, I prepared the talk for the students. I see very less number of students, but rest of the members I will make you interesting. I think you are all from diverse background: botany, zoology, physics, chemistry, biochemistry, life science as well, right? So, the title for today's talk is Bridging Biology with Nanotechnology. In the morning talk by Professor T.P. Radhakrishnan, who introduced about the so-called term nano, right? I hope he laid some foundation, but we will take a deep dive and see more complex phenomena at nanoscale interfaces and how it is addressing the key biological issues with respect to treatment of many dreadful diseases, right? So before going to the details, my lab broadly focuses on designing drug delivery systems against infectious diseases. Very specifically, we work on parasitic diseases. Also, we develop oral-based therapeutics, that is delivering a drug via oral route of administration. We are also interested in addressing the drug delivery approaches with respect to skin burns, that is the deeper burns, second, third degree burns, right? It is very difficult to treat the patients who are affected by the tertiary wound infection. So we are working in that line as well. And we are also trying to make some cardiovascular therapeutics. So this is the person who first termed the so-called nano phenomena. In a lecture at Caltech, Richard Feynman, he gave the famous quote, which is called, "There is a plenty of room at the bottom." That means at the atomic level, at the nanoscale level, he said, he speculated that time. It was not proven. Nobody has started working on this line. It is somewhere around 1956 to 59 time, right? but his famous, the quotation got very famous. People from then onwards started looking at the interesting phenomena that happens at the nanoscale. So nano is not something very new, though it was existing. We couldn't understand it at that particular point of time. So you can see here, these are the microtubules, and this is the kinesin which is walking. In that way, the motor movements in the human body is brought about by this simple phenomena. So it is happening at the nanoscale range. Means the nanoscale time point level, these events happen to perform the so-called motor transport phenomena what we see. So if somebody asks you how, like what exactly is the nanoscale and till what scale length you go and then you observe. So typically what is a nanoparticle is, you should know, understand that it is 1 to 100 nanometer. So you would have seen a scale, centimeter scale, right? 15 centimeter scale, the small scale what we use. So 1 billionth of a particular unit corresponds to the so-called nano. 1 billionth of a meter is nothing but nano. Okay. So for the first time, there is a scientist called Taniguchi who coined this particular term meaning dwarf, right? So typically in the day-to-day life, you see different objects. They may fall under macro, micro, and nano, right? So when you come to nano, you see the single hydrogen atom is nothing but it is in the nanoscale level. So people work in this range to understand why this particular nanoscale is important. In the consecutive slide, we'll be knowing. So for example, if this represents the Indian population, one individual in the whole population corresponds to nano, 1 nanometer, right? Similarly, if you have 100 crore rupees, 1 rupee of the whole 100 crore rupees is nothing but nano. That is 1 billionth of 10 to the power of minus 9 level. You go down, then you study the material. So what exactly is happening at this nanoscale? And accordingly, people classify nanometers into different groups: three-dimensional, two-dimensional, zero-dimensional. Right? We have quoted some example. So while getting down to from a bulk material to a nano material, when you go down, what exactly is happening and how it is contributing to whatever I have quoted in my introductory slides with respect to disease biology, right? So with a very well-known concept, that is the surface area to volume. In the morning lecture also, you have seen a football stadium, right? A football stadium with loaded with all the what you say, the participants who have come to sit there and watch the match, right? So when you take a material from the bulk to the nanoscale level, bulk to nano, when you take the material, the optoelectronic properties of the material, the physical properties of the material, the chemical properties of the material, they get an added advantage. These properties tremendously changes, which offers them for various biomedical application, electronic application, or even some making some kind of diagnostic kits, right? So this is a simple example which shows, like, as you decrease the size, the surface area to volume ratio gets increased. That is why the nano, the so-called nanomaterials, which are in the range of 1 to 100 nanometers, are very interesting for researchers to study, right? So in nature also, you would have seen many interesting phenomena that happen. That is nothing but mimicry or biomimicry. Actually, whatever the phenomena we are observing, I told you, for example, optoelectronic properties means the light when it is incident on a bulk material, the way it gets reflected, refracted, transmitted, these properties changes when you compare the same light which is incident on a nanomaterial, right? So most of the phenomena, I will give you some very good examples which are pictorially very nicely represented so that it becomes fascinating to you people to further venture into the so-called nano, right? So everything what we observe from the nature is what we try to mimic and then we try to learn from that. For example, there is a lizard in the house. You would have seen the lizard, right? The lizard doesn't have, it has legs, but how it brings that walking movement, it is nothing but on the surface of the leg, it has small nano structures. They are hair-like structures which can get in contact with the wall with the help of van der Waal forces. That is how the lizard on the surface. So this particular example I have given, this particular lizard is called eco lizard, and people got inspired. Everything now here, the interesting phenomena is just because of these nanostructures which are represented here. These nanostructures that are present on the foot of these eco lizards offer a tremendous advantages. It can lift almost some hundreds of kgs weight because of these van der Waal forces that act between the surface and the setae on the foot of the lizard, right? Again, taking inspiration from those things, there are some companies, pharma companies. For example, there is a company which made a biocompatible patch. So, under serious surgical procedures, there is a heavy loss of the blood, right? And you need to, the conventional way of addressing that is you make sutures. Now there are advanced sutures, antimicrobial coated sutures are available in the market, but actually still it has some hardship. So people try to mimic the gecko concept, which has those nano hair like structures which are patterned, they are arranged in a specific pattern. They got inspiration from that and they try to make a biocompatible patch that can be applied directly on the wound site and you can stop the blood. So yeah, this you can see here. So it can withstand up to 1 kg of the weight. They made a tape out of it. So they understood the nanoscale pattern arrangement of those setae, and then they try to make a tape which is called the gecko tape, which can withstand up to 1 kg of the weight and the maximum weight. The different concept which they have adopted and developed a product that can hold up to 134 kgs of weight. Again, you might have seen moth eye. Moth keeps its eye very clean. So when scientists tried to understand, they did a lot of microscopic experimentation and then they could see that on the surface of the eye, it has again the pattern structure. And these structures, the cone pillared structures, they are present in the a specific pattern. The arrangement of these nanostructures in the eye is very specific and pattern wise. So it offers water not to be present there. It forms a hydrophobic layer so that it keeps self-cleaning of the eye of the moth. So people try to mimic this concept and they make self-cleaning glass out of this. So whatever I'm presenting here, they are being made conventionally available. The commercialized product that has come out just because of the simple concept called biomimicry. And the fundamental aspect for this biomimicry is nothing but the nanoscale arrangement of the structures. Again, you might have seen chameleon. Chameleon, we say it changes the color, right? Now, what exactly brings in the change of the color is again, it is because the light when it is incident on these scales, the scales have a pattern structures which are at the nanoscale level, and according to the wavelength of the light, it is being incident and the light it is being absorbed. It gives different pattern structures. So, taking inspiration from this, people are trying to make some kind of glasses that can be like a fashion iconic glass, which can be used for different purposes. Also, fish and flowers. Fish, they are hydrophobic, right? If you touch the fish, you can observe it is very oily. So it is hydrophobic. On the other hand, there is a flower called skeletal flower. The flower appears something like this in on a sunny day, and when it comes in contact with the water, you can see it is transparent, almost transparent. So this flower is highly prevalent in Japan. So people adopted the hydrophobicity combined with the skeleton flower concept, and they're trying to make a deep sea like underwater optics. You want to image or you want to capture the deep animals, right, within the deep sea where there is no light. So these kind of materials can offer a escalating properties that they can be visible under the water in a very clear way, right? Similarly, you have seen the peacock feather. Peacock feather has different pigments and it has different layered structure. On the feathers, one kind of structural arrangement. On the neck, it has a particular spec arrangement. That is why it appears to be very deep blue colored structure when compared to the others. So everything is, what I'm stressing here is, it is all brought in just because of the simple arrangement of the nanoscopic particles, nanoscopic crystals or nano pillars that are present on the surface of the animals or their organs, and the way they take in light, they reflect it totally or they refract it. In the earlier case, the skeleton flower we have seen, the reason for the appearance of the transparent flower is diffuse reflectance, right? The phenomena that governs there is the diffuse reflectance. So at the nanoscale arrangement, the material properties changes. That is why nano is very important. You can see this particular wing of a fly. This fly is called a cicada fly. So when they observed on the microscope, it can kill bacteria. So then people got wondered how this particular fly has that antibacterial property. So it has some nano pillars arranged on its surface, and these pillars, they are pointed and they are patterned again. So when a bacteria comes in contact with these nano pillars form a pore on the surface of cell wall of the bacteria, and it break open the bacteria, leading to the death of the bacteria. So similarly, there is a beetle which lives in a desert condition, and it is requires water for its survival. So this has a sponge arrangement on its back which can absorb the water and store it in the form of this bottle. So they mimic this concept and they try to make a bottle which can collect water from the like if you keep it outside with the dew concept and coupled with the arrangement of these structures at the nanoscale range level. So this is called dew bottle. So these are some examples. Like at people, there is a lot of advancement in the textile industry because nowadays nobody wants to wash their clothes very regularly because we are all very lazy. So there are textiles like Levi's brand has already launched these jeans, t-shirts, which are highly hydrophobic. That means no dirt will be present on its surface. You just need them to dip in the water and it gets clean. If you ask me what about hydrophobic substance, if it falls, oil, ink and all, then we don't have answer for that. So I request you not to spill oil or water. Okay. But for other dirt removal and all, the concept. So the concept that is governing here is called the lotus effect. You can just do a simple literature search. You will come across this. Okay. And also this particular bird, which is called toucan, its beak is more length its body, but so and it is very lighter material. So when compared to the normal beak, when they observed the beak structure, what is it made up of, and how well they are organized. So people are trying to mimic this, and they are trying to make a car bumper which can avoid the so-called collision. So and also inspired from the shark skin, people are trying to make swimsuit. Okay, so far, yeah, this was literally meant for the students, just to make them more because Dr. Anil has said that sir, they are students from different backgrounds, so it is easy for them if you go by basics. So designing drug delivery system, and very specifically, can you give, like if you go to a doctor often you see he gives you injection or he gives you some kinds of pills also in the form of capsules or tablet format or sachet powdered format, right? But for many dreadful diseases, you just type in Google the top most dreadful diseases and what are their therapeutic options. You very unfortunate to see that most of the drugs which are given for like cancer, it is a dreadful disease, right? They all are hydrophobic. They are not friendly to the human body because you all know what human body is made up of. We are all made up of biological buffer. We have a buffering system. We have a temperature, right? Homeostasis brings in consistent body temperature. We have a buffering system, PBS. We maintain a pH of 7.4, room temperature of 37 degrees centigrade. So only things that can be stable at these optimal conditions will only survive. But the drugs that I told you, unfortunately, they are unstable in these pH conditions or they get degraded in those temperature zones, right? So, and if you ask a patient, whenever you visit a doctor, if a doctor tells you, Amma, I will write an injection for you or I will give you a pill, most of the people prefer pills rather than going to the injection because it is not very patient friendly route of administering a drug. We have different routes of administration: ocular, buccal, sublingual, oral, intravenous, intramuscular, subcutaneous. So these are all different formats in which a drug is being given to target a particular disease. But among them, like I said, oral route of administration is best preferred by the patient because they are friendly. You don't require any technician to administer a drug orally. If they prescribe, you can just take and then have it by yourself, right? Like I told, this is the major drawback. When you give medication in the form of intravenous routes of administration, that is, you inject the medicine directly into the systemic circulation, where we say because it is going into the circulatory system, once in the circulation, it can go to all the vital organs because everything is connected via the circulatory system, all the vital organs. So the drug is being channeled to all the vital organs. That is why we say for intravenous route of administration, the bioavailability of the drug, the presence of the drug in the biological system is 100% because it is just present. It is like a ship which is flowing when it rains, like you have a lot of water, you just put a paper, then it flows according to the direction of the water. It doesn't require or it doesn't get hampered. On the other hand, orally, when you take the drug, almost 50% of the drugs get degraded. This is the major obstacle, and this degradation is brought about because of the gastrointestinal tract. We have the GIT tract, which starts and ends in a varying pH condition, being highly acidic to neutral to highly basic at the intestinal lumen, and from there to the systemic circulation where it gets connected the digestive tract with the circulatory system. So the pH is highly fluctuating, and what are the drugs? Drugs are nothing but chemical compounds that are synthesized, are extracted, are purified from some natural resource, or some chemical analog that you make in the laboratory by using different kinds of chemistry mechanism. For example, the morning click chemistry. Click chemistry based anti-malarial analogs are also being made, right? So you have to keep the drug stable if you want to administer it via oral route of administration. So, like I said, most of the drugs they fail because they are either poorly water soluble or poorly permeable. Our body, like I said, buffering system, only the thing that is soluble in water is easily made bioavailable in the body. On the other hand, we are all made up of biological lipids, lipid by membrane, right? So a drug has to cross, if it wants to perform this activity, it has to enter the cell. In order to enter the cell, it should be permeable. Permeability should be there for the class of compound, right? Unfortunately, like I mentioned, cancer, all these drugs, they fall under class 4. This is a pharmaceutical classification. So this particular class 4, whatever you have seen, they are being widely used in the what you say in the clinical setting for addressing various diseases, right? So we have to address it. So you have to make the compound either more soluble so that it becomes more bioavailable, more permeable, so that more amount of the drug can be getting inside the cell, right? Like I said, the bigger challenge is the gastrointestinal tract. Sir, people, it's long years now. Why they didn't make? It is because the major obstacle was here. You have to keep the same system stable in the acidic environment, basic environment, neutral environment, and you want to get it released in the slightly basic environment so that it enters into the systemic circulation. So that is what our lab is primarily addressing. So this is the overall journey. Take the pill in the stomach. Approximately 40% of the drug is being degraded. And before entering into the systemic circulation, we have a metabolic center, that is the liver, where again maximal degradation of the drugs happen. Approximately 10 to 20% of the drugs again being degraded in the portal circulation, and only very few amount, approximately 20 to 30% of the drug goes into the systemic circulation. In your day-to-day life, in your home, you could have seen elder people taking a lot of medication and they often complain side effects. We have a lot of side effects. That side effect is arising just because of this, because we are taking more than what is exactly required. And why we are taking more? Because its bioavailability is less. So until and unless you take it in more number, you cannot counterattack the particular pathogen or the parasite or what a microorganism that is causing that particular disease, right? So we have to address this so that, and also the body has a particular mechanism called PGP efflux. That means PGP efflux identify chemical compound as a foreign compound and it throws out of the cell, right? Especially with respect to drug. Generally, it is a defensive mechanism for the cell, but when you take a drug, it is being thrown out by this PGP efflux mechanism. So we have so many complications. And the disease I will be talking, I will give you one clinical example where we try to develop a oral based medication that has some translational potential. We are in talks with companies with that particular compound. So leishmaniasis, it is a protozoan parasite, Leishmania donovani, which is a causative organism which causes the disease. The drug used for the treatment of this disease is amphotericin B, which falls under class 4, like I mentioned, poorly soluble, poorly permeable. And this is administered in the form of intravenous route of administration, right? So for 4 continuous hours, a patient has needles in the veins, and these drug is present in the form of a solution which is particulate. So now you imagine for 4 continuous hours, you have intravenous fluid that is going in against the flow of the blood, where the drug is present in the form of a particulate system. So the patient is getting cured by the drug, but is infusion related toxicity, hepatotoxicity, kidney toxicity brings in complications, right? So this is the burden, and India is hyperendemic zone for visceral leishmaniasis. Visceral leishmaniasis is one of the form of leishmania. It is a digenetic parasite. It has 2 hosts, sandfly and the human host. And the parasite is present in 2 clinical forms, amastigote and promastigote. This is the infective form to the sandfly. Like malaria, you have seen Anopheles mosquito. So this has 2. This is the sandfly infective stage. This is infective stage for human being. Now you want to design a drug which can kill both these stages as well, right? So this is the drug what I was talking about. So you are taking more than what is required, and then half of them is getting metabolized and is ready to be thrown out of the system. So where the kidneys plays an important role. Kidneys, it has an effective glomerular filtration rate. Kidneys, what it does, it forms excreta and it should throw out all the residuals that are not required for the body. It absorbs all the main constituents and then throw out. Liver, what it does, or it does metabolism. Active metabolism is brought in by the liver. So because of these pressure that creates on the kidney,
the so-called side effect in the day-to-day life, side effect, kidney or liver toxicity is brought in just because of this mechanism. And there is a drug which stands to be the first line drug for the treatment for the visceral leishmaniasis. It is called ampicillin, which is again a liposomal form of amphotericin B. That means amphotericin B, the parent drug, is conjugated. It is made in the form of a nano carrier system, and then it is being administered. But what is the disadvantage is it is given intravenously. Again, though it is a first line drug, it is given intravenously, and this requires refrigeration. And the patient who are getting affected by this particular disease is they are poor men. It is a hyperendemic zone in India in a district in Bihar called Muzaffarpur, which is highly like their poor community live there, and this parasite is very particularly prevalent there. So it requires cold storage means without refrigeration, the duck is you cannot keep the system stable. So now, what we try to do is we try to bring these bulk drugs at the nanoscale level by conjugating the active medicament, for example, amphotericin B, in the different kinds of lipid carrier system we explored. For example, this study was mentioning about solid lipid nano carrier. Means these are made up of lipids which are solid at room temperature. So you encapsulate, the drug is present. Earlier, the drug was present in the form of a tablet. It is a bulk powdered formulation that was compactized and then kept in the form of a oral pill, right? So now what we are doing, what we are trying to do is we are trying to take the same drug, but we are making a system called solid lipid nanoparticle system, which typically range in between 40 to 60 nanometer, right? You encapsulate drug inside the solid lipid nanoparticle, and you then surface decorate them because, like I said, designing a lipid-based drug delivery system is easy, but making it stable in the GIT tract is the most challenging thing. So that we are addressing by making different kinds of surface modification. The surface modification here are like beta cyclodextrin, which is called as the modifier, surface modifier. So we try to evaluate the potential of such kind of system, and then we tested their efficacy. See, when you observe under a microscopy, these nano structures look something like this, very patterned monodispersed particles in the size range of 40 to 100 nanometers. You can characterize them by using different kinds of physicochemical characterization technique as SEM, TEM, FDIR, XRD, right? And we have also performed the release of these particular formulation, whatever we have designed in the GIT tract as well as the physiological pH. And we have also performed long-term storage stability of these particular, because I said it needs to be addressed at the tropical climatic zone. So this particular system was stable till 45 degrees centigrade for almost like 3 months. We followed it up. And then we developed a disease model and we try to study the efficacy of the particular drug against that pathogen. So it was found to be like competing with the conventional amphotericin B that is given in the clinic. And we have also tested the toxicity effect. We have chosen some renal and hepatic markers. We try to evaluate the range of these biochemical markers present in the serum. So it was proven that there is a steady levels of the serum and the hepatic parameters, serum, hepatic and renal parameters remain consistent. So, so with this, we concluded, and after performing the in vivo testing, that these surface modification is very vital, where the drug is being loaded in the minimal concentration. If you give the repeated doses of these nano-based drug delivery systems also, the cytotoxicity is not that more when compared to the conventional drugs what we are taking in the form of the pill or infusion related toxicity, right? So I think I'll conclude here. Yeah. Thank you. Thank you.
Thank you very much, sir, for throwing a light on biomimicking related to nanotechnology application with many life examples. and route of administration of amphotericin B using nanotechnology to treat leishmaniasis. Now the forum is open for question and answers. Before that, first I'll ask simple small question. Sir, 50% of the drug, most of the drugs, 50% only be absorbed by the body and the 50% will be based. Okay, degraded. Out of which only little amount of the medicine will be okay. So whatever the amount, sir, it is getting wasted and it is affecting our kidneys and liver. Is there can we use this nanobiotechnology and apply some more extra things so that it can't be it can avoid our liver and kidney and go to the body. Thank you, sir. Thank you, sir. Now, any questions from the audience? If there are no questions, I would like to thank once again the complete organizing committee of this two-day national seminar. Thank you. I will hand over the mic. Good evening, all of you. I extend my heartfelt thanks to all of you. Especially, we are very much pleased to express my sincere gratitude to our resource person of this session, Dr. Shamlal, Associate Professor of and Department of Animal Biology, University of Hyderabad. On behalf of our life science team of NG College for sparing his valuable time to deliver a lecture on bridging biology and nanotechnology in medicine, sustainable drug discovery. All these days we are familiar with the words micro, macro, but rarely we did study about the nanotechnology. So nanotechnology, though we are studying, it is understood to be very small and minute. After listening to the address of the Dr. Shamlal sir, the word is understood in different dimensions, how it is useful in the research to find out versatile medicine to the different diseases. It was clearly presented through the graphs. Thank you so much for delivering such an important and engaging session about biomaterials for healthcare and molecular machines and nanoparticles and biomimetics, how to solve the complex human problems
It is very useful session to us. The use of nanotechnology in identifying the different diseases and finding suitable medicine contribute tremendously for the sustainable development. We are very thankful to you, sir. We are appreciate your willingness to share your knowledge and valuable session to our students. Your lecture was highlighting of our program. We are grateful to you. Thank you so much, all of you, giving this opportunity. And thank you so much, ma'am, Rupa ma'am, and all of our team of life science.
Along with their team members, botany zoology lecturers, please come forward so that we can honor our lecturer, Dr. Shamlal. Bouquet and this is the culture we have started with the fruit bouquet. This is the first time I think in Nalgonda I have introduced. If I give you a flower bouquet, you will throw it on the way. So that's why we have doing it.
Now it is the time to felicitate Tirumala Madam, Assistant Professor of Biochemistry, Mahatma Gandhi University. We are very much thankful to you, Madam, for coming here and acting as a chairperson to this session. All the faculty members, including resource person of this session, to felicitate the Madam. Please, sir, join the ceremony.
Thank you very much, the resource persons, chairman and rapporteur, and my dear students. It is the, I declare today is the first day, conclusion of the first day. Tomorrow at 9:30, we'll start online presentations and offline too. Those who are presenting and joined online, please submit your
PPTs to the concerned person, that the mail which I have given. All the students try to be here by 9:30 morning. Thank you. This is the end of the day. Thank you very much.
ఓకే బంద్ చేస్తున్నాయి సార్, బంద్ చేయలేదు సార్, బంద్ చేయండి. రేపు సాయంత్రం ఒక కాల్ వస్తే రేపు రాకపోవచ్చు. ఎంత కొట్టాను అంతే, ఉద్దేశం ఇక అయిపోయింది. వెళ్ళిరా, ఎండ్ ఉంది కానీ అయిపోయింది, నాది కూడా వస్తుంది.